This is Shuttle Launch Control at T-minus 4 hours, 33 minutes and counting. At this time, the countdown is proceeding smoothly here in Firing Room 1. The launch team is reporting no problems with the Space Shuttle Atlantis. The payload test team reports that Magellan and the inertial upper stage are also ready to fly. The shuttle weather officer is also reporting favorable weather conditions for launch time. So at this time, the status board here in Firing Room 1 is all green. The call to stations this morning was at 5 o'clock for the launch team to pick up the terminal count, and the NASA management team met to discuss the final decision to pick up tanking. There were no open items at that time, so at 5:34 the clock came out of a 1-hour built-in hold, and at 5:40 NASA launch director Bob Seek gave the go for tanking. At this time we stand at about 60% liquid hydrogen and 30% liquid oxygen on board the external tank, which holds about 550,000 gallons, 2/3 of that hydrogen and 1/3 of that oxygen. Looking ahead to the weather this afternoon, the forecast is calling for scattered clouds between 4,000 and 9,000 feet. The temperature about 88 degrees. The winds will be east-southeasterly, 10 to 15 knots, and the visibility 7 miles or greater. At this time, we have mostly clear skies here at the Cape with some scattered ground fog, which is forecast to burn off about 9 a.m. From yesterday, the winds are shifting somewhat around to a more southeasterly quadrant, so that improves the chances of meeting the return to launch site requirements of the shuttle landing facility should Atlantis have to make a return. And the cutoff, therefore, if the winds are east-southeasterly at launch time, would be about 15 knots, whereas if they were east-northeasterly, as forecast yesterday, they would be cutting off at about 12 knots. So the situation there has improved. Looking at Magellan, the payload test team had their call to stations last night at about 10:30. At shortly after midnight, the inertial upper stage test crew began the final alignment of the redundant inertial measurement unit, which is the guidance system on board. That work was completed about 2:45, and the test results indicate that was completed satisfactorily. At about 5:30 this morning, the Magellan crew had a status check of all of their systems, and they report that they have or are meeting all launch commit criteria at this time, and they continue to report that they are ready to fly. The flight crew remains asleep. They will be awakened at 9 o'clock this morning, about a minute before 9, assuming that all things are proceeding smoothly in the count. And at this time, we see no reason not to proceed with the wake-up call at 9 o'clock. And the countdown is expected to continue with a liftoff at 2:24 this afternoon. At T-minus 4 hours, 30 minutes, 25 seconds and counting, this is Shuttle Launch Control. This is shuttle launch control at T-minus 4 hours, 13 minutes and counting. Activity in the firing room is relatively routine. There is little activity on the management channels as there's not a great deal to discuss, and most of the launch team is going through the routine steps in the countdown procedure. The countdown has gone very smoothly, essentially no change in yesterday's status, and that there's just very little to discuss. The weather forecast for launch time continues to look favorable. The chance of a crosswind violation at the shuttle landing facility now is under 10%. So weather-wise and from a standpoint of the Space Shuttle Atlantis, everything is go. The payload test team also reports that Magellan continues to meet all of its launch commit criteria. The next significant event will occur at about 9 o'clock when we will enter a 3-hour built-in hold. At that time, the flight crew will be awakened and they will proceed with breakfast and a weather briefing, followed by suit up and going to the launch pad. They'll be leaving for the pad at about 11 o'clock this morning. At this time, the external tank continues to be filled with propellant. The liquid hydrogen tank now is at about 85%. The liquid oxygen tank at about 40%. Liquid oxygen is much heavier and requires a number of pumps to do that work, so it takes about an hour longer to complete filling the external tank with its load of oxygen. At T-minus 4 hours, 12 minutes, 15 seconds, this is shuttle launch control. This is shuttle launch control at 3 hours, 53 minutes, 59 seconds and counting. The countdown continues on schedule this morning, right by the manual. There are no problems in work. Currently underway is the aligning of the antennas at the Mala tracking station here at Kennedy Space Center, aligning their two large dish-shaped antennas with the launch pad and the space shuttle on pad B. Also downrange, the tracking stations of Bermuda, Antigua, and Ascension all report that they are ready and up and ready to support the launch. And the tracking and data relay satellite system, which will be supporting this mission, also reports go. TDRS 1, which is TDRS East, and TDRS 3, which is TDRS West, will be ready to support at liftoff. We have just gotten the results back of the last wind balloon, which was sent aloft about 3 hours ago. This is an upper air wind sounding, a gymsphere, and the results from that indicate that we have no upper wind concerns at this time, and we continue to not expect any for later this afternoon. There will be another balloon released, but at this time, from what we see on the current balloon, there is no reason to have any concern about upper air winds later this afternoon. The closeout crew and the ice inspection team are now at the roadblock. They will be going into the pad once the filling of the external tank is complete at about the time that we go into the launch minus 3-hour built-in hold. At this time, we stand at about 95% hydrogen and about 50% liquid oxygen. Again, the status board is green all the way across here in firing room 1. No problems being worked either by the Atlantis launch team or by the payload test team. At T-minus 3 hours, 51 minutes, 56 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at 3 hours, 34 minutes and counting. At this time in firing room 1, the launch team continues to have a very smooth and quiet countdown. Nothing out of the ordinary beyond the routine procedures. And the external tank continues to be filled with its propellant. Liquid hydrogen is essentially complete at this time, and liquid oxygen is approaching the 70% level. After we enter the built-in hold at T-minus 3 hours, then the ice inspection team and the closeout crew will be entering the launch pad. They are now at the roadblocks awaiting for those instructions. The shuttle weather officer has been reporting to Launch Director Bob Seek the downrange weather at the solid rocket booster recovery site, about 160 miles downrange. And the weather report from there is very calm seas, under 3 feet. And at launch time, there may be a few scattered rain showers in the area, but basically the weather at the SRB recovery site is very acceptable. Here at the launch site, we continue to have some scattered ground fog, which is expected to burn off between 9 and 9:30 this morning. The upper air wind balloon shows very satisfactory conditions aloft. Astronaut Dan Brandenstein will be flying the shuttle weather aircraft later this morning and just prior to launch to confirm that we have met all the return to launch site criteria for winds and other weather prior to the liftoff. Right now we're expecting winds at launch time to be from the east-southeast at about 12 or 13 knots, which would be within the crosswind criteria should that become a factor. Also, the weather overseas is excellent for the recovery site should we have to make a contingency landing. And at Morone, they are reporting essentially clear skies with northeasterly winds at 10 knots. The payload test team continues to monitor the health of Magellan and the inertial upper stage. The payload activity began last night about 10:30, and the IUS test team, consisting of Boeing and the U.S. Air Force 65 55th Aerospace Test Group, began configuring the IUS for launch at that time. At about 12:30, aligned the guidance system, which will be supporting the IUS and Magellan during flight, and that guidance check has been very satisfactory. Meanwhile, the Magellan test team continues to monitor the health of the spacecraft, and all conditions there look good. They have a trickle charge on the battery, which will continue till about 1 hour before launch. They will have a polling of their test team around the country, as well as at KSC, during the 3-hour built-in hold. Also, the Deep Space Network will receive their preliminary clearance to support the launch at Madrid, Spain, Goldstone, and Canberra, Australia, during that hold. So at this time, we continue to have a very smooth countdown, no problems to report. At T-minus 3 hours, 30 minutes, 30 seconds, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 14 minutes and counting. We're in the midst of a shift change here in Firing Room 1. The team that came on at midnight is preparing to leave, and those that will take us through launch later this afternoon are coming in. There is about a half-hour period where they share the console so that they become completely familiar with the activities which are underway and any problems which may be in work. However, from the standpoint of problems, we continue to have a completely green status board here at the Launch Control Center. There are no problems in work, so the transition is going well. This is probably a good point to sum up where we stand in the countdown. We're winding up the loading of the external tank with its propellants. The liquid hydrogen is essentially completely on board now, and we're approaching about 85% liquid oxygen. The closeout crew is waiting at the roadblocks to enter when we go into the L-3 hour built-in hold. They will proceed to the white room at the pad to prepare to support the astronauts when they arrive about 11 o'clock. The ice inspection team is also in position and waiting to go in when the hold begins to look for any ice that could break off and damage some of the shuttle tiles. Tanking began at 5:38 this morning after a go from Launch Director Bob Seek. The payload test team has, in the meantime, been monitoring the status of Magellan. Their last status check of all systems on board showed that they continue to meet all launch commit criteria for the spacecraft, and they have no significant items in work other than a trickle charge on the battery, which will continue until about 1 hour before launch. The team supporting the inertial upper stage began their activity shortly after 10:30 last night, and their most significant operation began shortly after midnight. It was completed about 2:45 this morning, and that was activating and aligning the onboard guidance system. The team has recently reported that that alignment looks good and that there is no need for a second calibration or alignment, which would be done at just about this point in the countdown should that need to be repeated. However, the inertial upper stage reports that they are go and continue to be ready to commit to flight. Reviewing the weather, at launch time, the updated forecast shows one layer of scattered clouds at 3,500 feet, visibility 7 miles or greater, a temperature of 87 degrees, east-southeasterly winds 10 to 15 knots. The latest upper air sounding from the Gymsphere wind balloon shows that we have a very quiet, benign situation aloft, and we do not expect that to change at launch time. The downrange weather for the solid rocket booster recovery ships is also excellent, with seas running between 3 and 4 feet, very light winds. They are predicting a few scattered rain showers in the area at just about launch time, but no activity which would preclude an SRB recovery. Tracking stations downrange all report they are go. Bermuda, Ascension, and Antigua all look good, and the Deep Space Network stations are currently being status for their capability to support Magellan after deployment later on tonight. The flight crew will be awakened very shortly in about another half hour or so. They'll be awakened about 9 o'clock. At that point, they will have breakfast and receive a status briefing on how the count is going, a look at the weather, and then they'll suit up and prepare to head for the launch pad. So all continues to go well here at the Launch Control Center in Firing Room 1. All the discussion is basically centered around the normal procedure. Management loops are quiet, no problems to discuss. So we remain on target for a launch this afternoon at 2:24. At 3 hours, 9 minutes, 44 seconds, this is Shuttle Launch Control. This is Shuttle Launch Control at 3 hours, 30 seconds and counting. We're preparing now to go into the 3-hour built-in hold. We've just had word from the propellants console that liquid hydrogen and liquid oxygen are now both in stable replenish, and that is exactly on schedule where we should be. So at this time, we'll be preparing to send the closeout crew into the launch pad. Going into the hold now in 3, 2, 1, 3 hours and holding. We are now in a 2-hour built-in hold. This sets the stage now for the 8-member ice inspection team to go into the pad and perform their work around various parts of the shuttle orbiter and the external tank to look for ice, which could fall off on lift-off and impact the shuttle. And the closeout crew will be proceeding to the white room so that they can support the astronauts when they arrive at the pad. The crew will be awakened at about 8:59 this morning. They will have breakfast and a weather briefing, then suit up for the pad just before 10 o'clock and depart for the pad about 10:39, arriving there shortly after 11 to begin their ingress into the white room. Here in firing room 1, we are now in what the launch team calls control switching. This means that the personnel are about to enter the pad, therefore it's a hands-off mode here in the firing room so that you do not inadvertently activate any system which could inadvertently propose a hazard to the ice inspection team or the closeout crew while they're in the pad doing their final closeout work. At T-minus 3 hours and holding, this is shuttle launch control.
This is shuttle launch control at T-minus 3 hours and holding. We have approximately 1 hour and 42 minutes left in this built-in hold. The closeout crew, which will prepare Atlantis for boarding by the flight crew, is in the white room now on the pad. The closeout crew is made up of 6 people: a closeout crew leader, a support astronaut, a suit technician, NASA quality control engineer, and 2 Lockheed orbiter mechanical technicians. The primary support crew astronaut, who you will hear referred to as the ASP on the communications network, is Bruce Melnick today. The ice inspection team also is on the pad, and they're on the mobile launch platform, on the deck of the mobile launch platform at the moment. This is an 8-person team, which basically has 2 jobs. One is to make a final check for any debris on the pad that could blow around at launch time and hit the shuttle. Their other job is to survey the external tank and the point where it connects to the orbiter to see if there are any indications of debonding of thermal insulation on the tank or any excessive ice or frost buildup which might break off during launch and hit Discovery's fragile tile system. All preparations continue to go very smoothly at this time, and we anticipate an on-time liftoff Atlantis at 2:24 p.m. this afternoon. At T-minus 3 hours and holding, this is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. NASA Test Director Ron Phelps has just been in contact with personnel over at the astronaut quarters and has given them permission to wake the flight crew in preparation for this afternoon's launch of STS-30. Crew wake-up is one of the major milestones in the countdown, as it signifies the launch team's confidence that the vehicle is ready for launch. Normally, if a significant problem existed at this time, the crew would be allowed to continue sleeping because flight directors have determined over the years that they don't want the astronauts to have too long a workday from wake-up to the start of their first sleep period. However, in the case of a very short window like we have for Magellan, that's not a consideration, and the people here in the Launch Control Center figure that probably the crew woke up before this. Nevertheless, it's part of the countdown, and the go has been given. Some of the restrictions as far as the flight crew is concerned is maximum time in the cockpit strapped inside their seats that cannot exceed 6 hours. Once they're awake, the crew will have their traditional breakfast, get a last-minute weather briefing, put on their flight clothing and gear, and prepare for the 9-mile trip to the pad. Everything has been going very smoothly in the countdown. We have approximately 1 hour, 32 and a half minutes remaining in this 2-hour build-in hold. This is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. The ICE team has been working on the pad on the 0 level, or the deck of the shuttle's transportable launch platform, to inspect the tank's aft dome and the shuttle's engines. Their next step will be to go up to the 135-foot level, which will permit them a good view down on the orbiter to external tank umbilicals, and then on to the 195-foot level, which is the point where the crew access arm extends from the service tower over to the vehicle and affords a view of the orbiter's forward attach point to the external tank. Their next stop will be at the 215-foot level, which corresponds to the very tip of the external tank. From there, they can see how effective the beanie cap, or gaseous oxygen vent hood is at collecting the gaseous oxygen vapors and preventing them from forming ice on top of the external tank. They'll make one last stop again on the 0 level of the mobile launch platform before concluding their inspection and returning to the Launch Control Center to report back to senior shuttle management on what they saw and how it compares with previous launches. The ICE team has an exacting job. It's one of the actually dangerous jobs because once you've fueled the shuttle, there is always a certain amount of danger from the mass of propellants and energy that's out there. The ICE team's made up of 8 members. The ICE team leader is Charlie Stevenson with NASA. There's an infrared scanner operator, Greg Katnick, a handheld infrared scanner, Farouk Handaidi, close-up photo documentation, Zach Burns, a tank manufacturing expert from Martin Marietta at Michoud, where the tank is made, Steve Copsey, data collection, Randy Seal with Lockheed Shuttle Processing, NASA photo documentation, Robert Spees of NASA, and a Lockheed safety representative. Once they have completed their work out at the pad, they then come back to the Launch Control Center where they report to the launch director on what they saw out there and their assessment of how the insulation is on the external tank and also how all of the connections between the external tank, the main propulsion system, and the orbiter are. A danger could occur if there was too much of an ice buildup, which might shake loose during launch, or there was some ice which prevented the engines, the main engines on the orbiter, from gimbaling properly. So they take a look all around those surfaces using both instruments, binoculars, and their eyes to see how things are out there. Today they have one other additional task. Some special instrumentation was placed on the area near the 17-inch disconnect between the external tank and the orbiter to make sure that there is no seepage of hydrogen during the tanking process. And they will pull that instrumentation off prior to returning here to the Launch Control Center. Everything going smoothly, T-minus 3 hours in holding, about 1 hour and 25 minutes remaining in this built-in hold. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. We have just heard back that the last weather balloon to be analyzed through the computers turned out to be very, very satisfactory for this morning or this afternoon's launch. The upper level winds are just exactly as predicted, and at this time there doesn't appear to be anything that will need to be changed in the computers as far as the loads on the shuttle are concerned during launch. In addition to the ICE team and the closeout crew preparing for the astronaut arrival, there's also a rescue crew on hand at the roadblock leading to the Pad B. And that team is made up of rescue workers, paramedics, and also 2 drivers are on hand at the bunkers just adjacent to the pad on the perimeter to drive the M113 armored personnel carriers if a fast exit from the pad by the workers is necessary. They're stationed at the slide wire bunker, and they remain there until the closeout crew and the ICE team have left the pad. Then they leave one of the M113s there with the engine running in case the flight crew should need it in an emergency. One of the tasks which was underway was power transfer and thrust vector control checks of the inertial upper stage, or IUS, which is used to propel the Magellan spacecraft out of Earth orbit and on its way to Venus. These checks verify that the flight batteries will carry the required loads and that the thrust vector control system which steers the motor on the IUS is working properly. A little earlier, NASA Test Director Ron Phelps asked all the orbiter test team to switch to the same communications channel to ensure that everyone's on the proper channel when the astronauts enter the orbiter and begin their communication checks and other tasks to prepare for launch. The ICE team is just reporting that they have completed their work on the mobile launch platform and talking about the path that they're going to take as they go up the stack to survey any buildup of ice that might occur. The countdown clock at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. We have approximately 1 hour and 6 minutes left in this built-in hold. We come out at 10:34 Eastern Daylight Time. We're standing by to join the astronaut crew for STS-30 as they start their breakfast. However, out on the pad, there's a lot of activity going on to prepare the way for them to come out. The team up in the White Room consists of 6 people. A astronaut, the astronaut support person, Bruce Melnick, who is inside the orbiter. There's a closeout leader, Paul Arnold. 2 suit technicians, Carol Bernhard and Steve Crosby. A tech, Dwayne Waters, and Jay Sullivan, who is the NASA quality control person. Their job is to make sure that everything is in readiness for the crew to get out there. Among other things, they cover up the proper switches so that the crew doesn't brush against them. Also out on the pad is the ICE team. They're on the 134-foot level, taking a look at the connections between the external tank and the orbiter. They have instruments which take a look in the infrared at the tank because some things just are not visible. What they do is they are measuring the temperatures that they see, and they can tell from that if there is any frost beginning to build up that might not be visible to the naked eye, and also whether there's a potential. It would show a leak of the cold from inside the tank out through the insulation to the outside if they should see that. Earlier in the morning, of course, there was quite a lot of fog here. That is basically burned off, but there's always humidity here in Florida, which can condense on the tank if the conditions should be right. They use a bucket of ice water for calibrating their instruments out there, just as you might use a photometer for calibrating the amount of light that you would use with an ordinary camera. Everything going smoothly here in the countdown. The weather is looking extraordinarily good for this morning's launch. A weather briefing is in progress right at the moment, one of several that occur during the countdown. We are just hearing that if there should be a necessity of a return to launch site abort, that we would use runway 15. On the NASA television circuits, we're about to join the astronaut crew for their pre-launch breakfast. The crew has a wide variety of breakfast items to choose from, ranging from cold cereal to steak and eggs, juices, milk, and other beverages. They're in the crew quarters. In the center is Commander Dave Walker. Going from left to right is Norm Thagard, the mission specialist 1 on this flight. This will be his 3rd flight. The pilot, Ron Graby, also a space veteran. The commander, Dave Walker, 44, flew on board 51A. Mission specialist Mary Cleve She's logged 165 hours in space, and Mark Lee, the only rookie in the crew, just 36 years old. He's a major in the Air Force and a member of the astronaut class of 1984. On the table in front of the crew, as usual, is a cake decorated on top with the official STS-30 crew patch. This symbolizes the mission. In this case, it depicts the joining of NASA's manned and unmanned space programs. On the pad, the closeout crew continuing with their efforts. That cake, by the way, is not eaten prior to the crew going out to the pad. It's frozen and saved for them to have when they return back to Houston from their flight. Everything going smoothly here in the countdown for launch of STS-30. The countdown clock at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. We have approximately 54 minutes remaining in this 2-hour build-in hold. During this period, the supply of drinking water must be monitored on board the orbiter to ensure that there's enough room to accept water being made by the fuel cells. If it's decided that not enough room exists, the water will be drained from the system to get back to the proper level. Normally, during this 3-hour hold, they attempt to drain to 5% of the 20-gallon tank capacity, and the plan is to have 50% of that tank full at T-minus 0. There's actually a constraint that's built into the launch commit criteria, which says that if the water exceeds 83% of the capacity of the tank at T0, that you would have to stop and do a drain. The purpose of the water is twofold. One is for drinking water for the crew, and the fuel cells, of course, are producing water continuously all of the time that they are on and all of the time they are in orbit. That is dumped overboard periodically, which it's certainly more than the crew can drink. And it also is used, just small amounts of water are used in the water spray boilers, which are used for cooling the auxiliary power units, which produce the hydraulic power for the aero surfaces and for gimbaling of the main engines on board during the liftoff. We've just had a word from the weather people to Launch Director Bob Seek on the weather today. The weather is exceptional as you look out there. At T0, it's expected that there will be a few scattered clouds at 3,500 feet. Visibility will be 7+ miles, and the temperature 87. The only concern is what will happen as far as the shift of the winds which are blowing. Right now, they're coming from the southwest at 10 to 15 knots. This creates a crosswind problem on the runway. The runway is oriented just 30 degrees off of north and south, and we don't want to have any more than 15 knots crosswind. However, the sea breeze should start turning that around sometime between 2 and 3 o'clock this afternoon. And, of course, it does not announce in advance when it's going to come in, but we expect that it will have shifted from southwest to east-southeast by the time of launch, and will be still approximately 10 to 15 knots, but will produce less crosswind. This would allow a landing on runway 15 if a return to the launch site were necessary. The sea breeze is a phenomena that occurs here during the afternoon, and what will happen is we will gradually watch the winds hopefully shift from southwest to east-northeast and then to east-southeast. And that should happen within the window that we have, the 23-minute window for launching of Atlantis in Magellan today. All of the other tasks which are going on during this T-minus 3-hour hold seem to be going well. The countdown clock still holding at T-minus 3. This is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. At this point, the satellite is being switched to provide for the astronaut weather briefing. The flight crew completes its breakfast in the crew quarters, and then Commander Dave Walker and Ron Graby settle down for a weather briefing that comes from Mission Control in Houston. And we'll check now with Mission Control to see how things are there and what's happening.
This is Mission Control. The satellite video has been switched to originate from JSC, showing the weather satellite charts that will be used by the Mission Control team for the weather briefing, which is scheduled for L-minus 4 hours and 25 minutes, about 10 minutes from now. Here in the Mission Control room in Houston, flight controllers of the ascent team have reported for their ascent shift, have completed their handover, and all systems are looking good for launch at our planned time today. This is Mission Control.
This is shuttle launch control back at the Kennedy Space Center, still at T-minus 3 hours and holding. During this period that the commander and the pilot are getting their weather briefing, the mission specialists begin their suiting up process just down the hall. The briefing addresses the weather patterns in the vicinity of the launch pad, as well as all of the various contingency landing sites which are located across the Atlantic Ocean in Africa and Spain. The primary contingency landing site is Ben Guerir, Morocco, with a weather alternate of Morone. However, in certain conditions, depending on what should occur, a landing could also occur in the Gambia at Lumdum Airport there. The weather briefing, of course, also looks at Edwards Air Force Base in California, White Sands Space Harbor in New Mexico. That weather conference is carried via satellite from Houston and beamed into the crew quarters and also the Launch Control Center. Once that's over, then the commander and the pilot also will go down to the suit room near the crew quarters to get into their pressure suits for launch. If we had needed to do another alignment of the inertial navigation system on board the inertial upper stage in the payload bay, that could have gotten underway during the last 15 minutes or so. However, the original try worked out properly, and that was not necessary. The IUS, or inertial upper stage, is a rocket stage which will be used to carry the Magellan into from low Earth orbit, and boosted into a trajectory around the Sun, which will intersect the orbit of Venus. The IUS is the most advanced upper stage, the most powerful one that we're using on board the shuttle at the present time. It has a completely redundant avionics system which can correct any in-flight problems within milliseconds. The IUS is 17 feet long, 9 feet in diameter, and weighs more than 32,000 pounds, including 27,000 pounds of solid propellant. It has 2 stages. The IUS has its own, actually, operations control room. As part of the operation here, the IUS is managed by the Air Force and was developed under the Air Force direction. There actually are several control rooms which are in operation here at the Kennedy Space Center as well. The Magellan project also is making use of control rooms which are over on the Cape Canaveral side, which were used for expendable launches primarily. This is the first launch of a interplanetary mission using the shuttle, and previously it had always been on expendable vehicles such as the Atlas Centaur, and so those control rooms are located across the river where the spacecraft is monitored and the health of the entire system, including the deep space network. Right at the moment we're taking a look at what contingency sites might be satisfactory. The weather overseas is not great, but it looks like that it will be acceptable for the launch. The countdown clock at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. We have just 34 minutes remaining in this built-in hold. The closeout crew and the ICE team are continuing their work out there on the pad. The ICE team members look a little bit like they're dressed in the same pressure suits as the flight crew. However, those are really non-static producing flame retardant coveralls. And they also all carry a gas mask for emergency use. They have a variety of equipment for performing their inspection, and right now they're up near the tip of the orbiter taking a look at the external tank. They have binoculars, a telescope, and a special infrared scanner that's used to determine the skin temperature of the tank in any spot that they choose. The scanner works in the same manner that the TV camera does, except that it's looking in a different wavelength of the spectrum. That's really the key to the success of the Magellan spacecraft as well. Venus is clouded to such a heavy layer and so opaque that normal pictures taken in the visual portion of the spectrum simply can't see through the clouds. And therefore, the Magellan carries a instrument, which is radar, side-looking radar, which can penetrate those clouds because it is using a different portion of the electromagnetic spectrum. In the case of the ICE team up there, they calibrate their infrared sensors by using a bucket of ice, which works pretty much the same way that white paper or cardboard uses with people who have to balance their TV cameras. The ICE crew inspection continues to go smoothly at time, and no major problems have been reported. 31 minutes, 40 seconds remaining in this built-in hold. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. 25 minutes remaining in this built-in hold. The Landing and Recovery Director, Chuck Henschel, is going through a series of communications checks with the convoy commander who is standing by at the shuttle landing facility in the case of a problem which requires the shuttle to abort its mission and return to the Kennedy Space Center after launch. He is also talking to the solid rocket booster recovery ships, the Liberty Star and the Freedom Star, which are standing by to recover the solid motors about 142 miles east of the Kennedy Space Center. The Freedom Star and its sister ship, Liberty Star, departed from Cape Canaveral yesterday. Takes about 24 hours or so. They go through an approximately 2-hour electronic and visual search of the impact area to ensure that the area is clear of shipping. At T-minus 30 minutes, the ships will be located 7.5 miles from the predicted impact point for the solid rocket motors. Impact of the solid motors occurs about 7 minutes after liftoff. Even though they burn out and are jettisoned 2 minutes after liftoff, they continue to fly on a parabolic trajectory until they impact in the ocean. The recovery operation itself, given good seas, and the seas are very good today, takes about 5 hours. The commander, Dave Walker, and pilot Ron Graby have moved from the place where they were watching the weather forecast from Houston in the crew quarters down to the suit-up room. And in just a few minutes, we'll be having some scenes from the suit-up room. In the meantime, out on the pad, all of the preparations continuing to be prepared for their arrival. The ICE team completing their work up on the 212 level of the service structure out there, taking a look at every connection and every place on the external tank that they possibly can, just to ensure that the insulation is secure and there's no leakage of the extreme cold from the liquid hydrogen and the liquid oxygen that could lead to an ice buildup. Just a few minutes from now, the astronaut support person, Bruce Melnick, will be asked to install the lithium hydroxide canisters in the crew compartment. These canisters are part of the cabin air revitalization system. Cabin air is ducted through 2 lithium hydroxide canisters, which removes carbon dioxide, and activated charcoal, which removes odors and trace contaminants. The canisters are changed alternately every 12 hours during the mission. Other systems monitor and provide the proper mixture of oxygen and nitrogen for breathing and maintain the proper pressure, humidity, and temperature. One complete cabin air change or cycling occurs every 7 minutes. About 21 minutes remaining now in this build-in hold. There will be 2 more build-in holds in the countdown as we progress toward a liftoff at 2:24 p.m. this afternoon. Normally, both of those holds, which occur at T-minus 20 minutes and T-minus 9 minutes, are 10 minutes in length. However, because of the short window for the Magellan spacecraft, we will extend the T-minus 9 minute hold to 40 minutes today. That allows time for the managers, the test conductors, the launch director, and the mission management team to discuss any issues that there might be at that time and arrive at a considered opinion with no pressure on holding up the launch because of the shortness of the window. The window for Magellan is based on really 2 considerations today. It's based primarily, the opening of the window is based primarily on launching the shuttle with enough propellant to maneuver to get into the proper plane or the proper orientation to the Earth's surface and to the planet Venus to launch Magellan with the least amount of energy necessary to get it on the proper trajectory. Actually, the orbiter will go through a maneuver on its flight into orbit in which it will yaw or move sort of sideways if you were looking at it on a tracking chart in order to get into that proper plane or orbital plane around the Earth. The second consideration is the lighting at the transoceanic abort site. The rules call for there to be enough daylight for the crew to make a landing when they can see the runway satisfactorily. Of course, as you go toward the east, the sun sets earlier and earlier in relationship here. So at the end of the 24-minute window or 23-minute window is the last minute that you can launch and still have daylight at one of the African sites if it were necessary to fly there. One of the tasks that is going on right at this moment is a check by the Magellan team to report on whether their spacecraft is ready. Everything appears to be going well, though, as they go through those steps, and will report on the completion of that shortly. The countdown clock at T-minus 3 hours and holding, a little less than 18 minutes remaining in this filled-in hold. This is Shuttle Launch Control. Clock still at the T-minus 3 hour point and holding. The suit-up process has changed during the period that the shuttle program has been underway. From STS-1 to STS-5, the crew wore pressure suits during the launch and the descent period from orbit. Then starting on STS-6 and until STS-26, the crew wore coveralls during launch, and this allowed them to sleep later and have a much shorter period of preparing for their trip out to the pad. However, a change in that process was necessary when the decision was made to install an escape system on the orbiter. That escape system provides for the crew to be able to exit through the regular hatch on the orbiter while it is in straight and level flight if it would not be able to land at a regular landing spot. Each crew member would hook onto a pole which would be positioned outside the door, fasten their harness to that pole, jump out and slide down the pole far enough to ensure that they would not impact any of the orbiter's surfaces. In order to be able to depressurize the cabin during that sort of emergency, and also to bail out at a high enough altitude, it's necessary for the crew to have a pressure suit and, of course, to have self-contained oxygen and their usual launch and entry helmets, which have been modified from the ones used during the earlier part of the shuttle program. In the suiting room, they put on those pressure suits. However, it is not until they get out to the pad that they put on their parachutes, communications cap, and other survival equipment just prior to entering the orbiter. This is shuttle launch control in the suit-up room. The crew going through the process of checking out their equipment. They actually will be not going out to the pad with the helmets on. Commander Dave Walker, in the process of getting some of the survival equipment and also the things that they might need during the ascent phase into the various pockets which seem to cover this type of pressure suit. Walker is 44, and he flew as pilot on the 51A mission aboard Discovery in November 1984. Over on the other side of the room, our mission specialists Mark Lee, who's the only rookie of the crew. He's a major in the Air Force and a member of the astronaut class of 1984. Right next to him is Mary Cleve, who will be known as MS-2 or Mission Specialist 2 during this mission. She flew aboard Atlantis in November of 1985. That crew deployed 2 communication satellites and demonstrated space station construction techniques with the EASE Access experiments. Mary Cleve is a PhD with expertise in the environmental area, worked as an environmental engineer during an earlier part in her career. And although that's not entirely related to her task on this particular launch, it is very appropriate because one of the main missions of the Magellan spacecraft and all of the spacecraft which have been launched to Venus so far is to find out how this twin of the Earth in the solar system evolved into such an inhospitable planet compared with the planet Earth. And hoping that scientists hoping to learn what happened there to help prevent that from happening here on Earth, with people tinkering with the atmosphere and with the environment that supports the life on Earth. Out on the pad, the preparations continuing. We expect to see the crew next departing for the pad just a little shortly after we pick up the countdown again at the T-minus 3-hour point. And we have just had a report from the Magellan mission manager that Magellan is ready to resume the count. All spacecraft systems are go. Just a little more than 10 minutes remaining in this built-in hold, and the clock will start once again at the T-minus 3-hour point. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. 2 minutes remaining in this 2-hour built-in hold. There are 2 more planned holds. The first comes at T-minus 20 minutes and the second at T-minus 9 minutes. The one at T-minus 20 minutes will be 10 minutes in duration as usual, but because of the very short launch window for Magellan today, just 23 minutes, the T-minus 9-minute hold has been extended by a half hour, so that'll be 40 minutes altogether. About a minute and a half now before the end of this hold. Out on the pad, the ICE team is just completing their work, and we expect to have them on their way shortly. Back on the mobile launcher platform number 1. Up in the White Room, everything going very well as they prepare for the crew to come back. Each one of the closeout crew has a number on them, and that's to aid in identification. Number 5 being a Lockheed technician. Number 6 is the NASA quality control person. The flight crew will be leaving the crew quarters just about 5 minutes from now, 5 minutes from the time that we pick up the count once again, and that should occur in about 20 seconds from now. 10 seconds to release of hold. And we're at T-minus 3 hours and counting. The ICE inspection team reporting that it's completed its work and will be leaving the pad shortly. They'll report their findings to Launch Director Bob Seek when they reach the Launch Control Center. Pressurization of the helium tanks for the main propulsion system also gets underway at this point in the countdown. This is a task that takes approximately 30 minutes. The 30 minutes used to fill the 10 helium tanks in the main propulsion system is really a function of decreasing the potential heat buildup in the supply tank which will prevent the maximum amount of helium to be loaded on board. The helium supply provides pressure to operate the liquid oxygen and the liquid hydrogen pre-valves and onboard and inboard fill and drain valves, and it's also used for anti-icing purges of the three main engines. At this point, the crew informed at the crew quarters that everything is proceeding and that they may depart to come out to the pad. We expect to see the crew just 3 or 4 minutes from now. And just prior to that departure, there'll be one more check with weather to ensure that there's no electrical storms within 5 miles of the launch pad. But looking around here, people can see that that is the case today. At the at the ONC building back in the industrial area of the Kennedy Space Center is where the astronaut crew quarters are located. And as those of you who can watch the NASA Select television, there is a large crowd of people who are waiting there to wave to the crew and wish them a good journey on the Atlantis. Final preparations in the firing room are continuing to get the launch processing system in its final launch configuration. NASA Test Director Ron Phelps calls the crew quarters and has verified that the test team and orbiter are ready to support the flight crew's departure from the crew quarter and subsequent arrival at the pad. The crew is presently in the suit-up room on the 3rd floor of the ONC building, and you'll see them come down a hallway to an elevator which will take them to the ground floor, where they'll leave the building and climb into the waiting astronaut van. The countdown clock at T-minus 2 hours, 56 minutes and 30 seconds and counting. This has been a very smooth countdown ever since it was picked up 2 days ago. Only very, very minor problems have occurred. One ding in a thermal protection tile was detected when the rotating service structure was moved away from the stack last night. And that, of course, was fixed. Only takes a relatively short time to do that. Since this launch occurs during the normal working hours, there's more than the usual crowd of well-wishers at the ONC building waiting for a glimpse of the crew, headed by Commander Ron Walker, or Dave Walker. The flight crew has been basically isolated from people who have not been examined to determine that they will not pass on colds, viruses, and that sort of thing the entire time that they've been here to Kennedy and for a time prior to their departure from the Johnson Space Center. It's necessary to keep even well-wishers back from them because it would not do to have somebody come down with a cold while they're in orbit. It might not be serious, but it wouldn't be comfortable either. And coming out now, Mission Specialist Norm Thagard, the pilot Ron Graby, Mark Lee, Mission Specialist, and Mary Cleve, and the Commander Dave Walker bringing up the rear. Dan Brandenstein, who is the head of the astronaut office, is going with them along with Rick Nygren, astronaut trainer, and Don Putty, who is the director of that directorate at the Johnson Space Center. They're in the elevator and on their way down to the 1st floor. There's a group of news media representatives as well as well-wishers gathered near the elevators and in the breezeway. And standing by is the astronaut van, which will take the crew to the launch pad about 9 miles away. And here comes the crew. You can see a sign waving there. Leading the group is the Commander Dave Walker, Ron Graby, pilot, Norm Thagard, Mark Lee, and Mary Cleve, mission specialist. Going out to the Astro van, which is a converted recreational vehicle, to take them out to the pad. It's rather cumbersome walking about or trying to get into most vehicles in those pressure suits, and that's why with the equipment needed and the number of people that sort of vehicle can be used. Finally, the door will be closed by NASA security specialist. And then the crew on their way to the pad, where the shuttle vehicle has taken on new life since they saw it last. It's breathing steam, has a super cold propellants causing creaking and groaning from the metal, contracting and expanding as first it's chilled and then heated by the sun rising in the sky. On the way to the pad, the Astro van will have a security force and a medical escort, and some of the people who are streaming into the center to view the launch may get a brief glimpse of the 5 crew members through the windows as the convoy speeds by. We're now less than 4 hours away from the launch of Space Shuttle mission STS-30, America's return to interplanetary exploration, the flight of Magellan. The Astro van moving off as they get on their way out to the pad. The team here in the Mission Control Center and in the Launch Control Center at the Kennedy Space Center, taking a look at some of the contingency plans and any problems that there might be. The countdown clock at 2 hours, 51 minutes, and 10 seconds. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 2 hours, 48 minutes, 4 seconds, and counting. The flight crew in the Astro van has made its way into the LC-39 area. During the trip out to the pad, they do stop at a couple of places to let people off. At the intersection of the Saturn Causeway, which they're on now, and the Kennedy Parkway, they let off Dan Brandenstein, who is the chief of the astronaut office and the person who will be flying the weather aircraft. Then here at the Launch Control Center, they left off Director Don Putty of the flight operations from the Johnson Space Center, and Rick Nygren, the astronaut trainer who is assisting the crew. And then only the people continue on to the pad who actually are necessary out there. The flight team and the person, of course, who's driving the Astro van. They are accompanied, of course, by security and by medical support as they go out to the pad, where everything is in readiness for their arrival. For the last couple of hours, the closeout crew has been preparing for their arrival, and things are ready. Otherwise, the crew would have been kept back at the crew quarters. The countdown clock at T-minus 2 hours, 41 minutes, 18 seconds and counting. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 2 hours, 38 minutes, 25 seconds and counting. The Astro van has made its way past the roadblocks and is proceeding towards the pad. We'll be arriving there in just a minute or so from now. Once they get to the pad surface, the crew will get out and take the elevator to the 195-foot level of the fixed service structure. They'll walk across the crew access arm and into the White Room, where they will put on the rest of their escape equipment and helmets before entering the orbiter. The closeout crew is making final preparations for the crew's arrival. Switches in the cockpit have been covered by astronaut Bruce Melnick, so as to ensure that crew members do not inadvertently cause the reaction control jets to fire if they should brush against the controls in their bulky pressure suits while getting into their seats. Switches have also been configured to the proper settings to prepare the vehicle's electricity-producing fuel cells for using the onboard cryogenic reactants when ground supplies are terminated about 3.5 minutes before liftoff. Orbiter navigation aids, the tactical air navigation, radar altimeters also have been activated. The Astrovan proceeding on the roadway very close to the pad now. Shortly will be up on the pad surface, and the crew going up the elevators to the 195-foot level. The countdown clock at T-minus 2 hours, 36 minutes, 30 seconds and counting. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 2 hours, 34 minutes, 22 seconds and counting. The astronaut van has arrived at the pad, and the crew has gotten out and is going up in the elevators, which will take them to the 195-foot level. The STS-30 Lockheed Orbiter Test Director, Mike Key, polled all of the various test conductors and verified there was no violation of the launch commit criteria prior to them coming out of the Astrovan. And the astronaut support person, Bruce Melnick, reported that that he was ready for the crew ingress. Commander Dave Walker and pilot Ron Graby, along with Mark Lee, are in the White Room at the present time. Actually, the commander and the pilot will be the first to complete the suit-up process and to enter into the orbiter. They have a somewhat more difficult time in getting into their seats because of the adjustments which must be made to ensure that they reach the rudder pedals properly and are able to reach all of the switches and the control panels that are necessary. Just a few minutes ago, we heard from the ICE team leader, Charlie Stevenson, who has passed back through the checkpoint on his way back to the Launch Control Center to give his report on what his team saw on the mobile launch platform and on the various levels of the service structure. One of the things that they look for, in addition to any icing conditions, is any bits of loose hardware that might be around that could be kicked up by the power of the engines at the time of launch. In the White Room now, each member will in turn put on escape equipment over their altitude protection system clothing. That equipment consists of an emergency oxygen system, parachute harness, parachute pack with automatic opener, consisting of a pilot chute, rogue chute, and main canopy, a life raft, 2 liters of emergency drinking water, flotation devices, and survival vest pockets, including a radio beacon, signal mirror, shroud cutter, pen gun flare kit, sea dye marker, smoke flare, and beacon. Actually, all of this is packaged in as small a unit and as lightweight as possible, so as not to add additional weight or bulk or prevent any of movements of the crew in the performance of their duty during the ascent or the descent part of the mission. Commander Dave Walker and pilot Ron Graby will put on their launch and entry helmets when they're in the crew compartment. The rest of the crew will put them on prior to entering the orbiter. It takes approximately an hour for the entire crew to enter the orbiter and be strapped securely into their seats. Commander Dave Walker and pilot Ron Graby will be the first to enter the orbiter. They'll be followed by Mary Cleve, Mark Lee, and Norm Thagard. The shuttle countdown continuing. We've just passed the 2-hour and 30-minute portion of the count. Commander Dave Walker being helped on by the technicians with the remainder of his emergency equipment. He's a captain in the U.S. Navy, and he was selected for astronaut program back in 1978. He flew as pilot on STS-30, which, in addition to deploying 2 satellites, Canada's Anik D2 and a Hughes LeeSat, his crew also retrieved Palapa and Westar. This was the first time satellites had been retrieved in orbit and returned to Earth. Walker was born in Columbus, Georgia, but he considers Eustis, Florida to be his hometown, and he's a graduate of the U.S. Naval Academy at Atlantis. Ron Graby completing his suit up here prior to going into the cabin. He's a colonel in the U.S. Air Force. He flew as a pilot on STS-51J in 1985, which was the second space shuttle mission for the Department of Defense. He's a graduate of the U.S. Air Force Academy. And Commander Dave Walker, getting into through the crew compartment access door, while Ron Graby completes his work. Graby is a native of New York City, and he served as an F-100 pilot in Vietnam, where he flew 200 combat missions. After graduation from the Air Force Test Pilot School at Edwards, he served as a test pilot for the A-7 and F-111 aircraft. He later was an exchange test pilot with the Royal Air Force from 1976 to 1979. And during that time, he was a chief project pilot for the Royal Air Force Harrier and the Royal Navy Sea Harrier. In 1981, he was selected for the astronaut program by NASA. The countdown continuing at T-minus 2 hours, 27 minutes, 25 seconds, and counting. This is Shuttle Launch Control.
OTC CMPS. Go ahead, MPS. Yes, sir. Could you ask CASGAS to come over to 166 at his convenience? HTD OTC. This is HTD. Go ahead. Can you go over 166, please? Copy. Thank you. OTC CMPS. Go ahead, MPS. Yes, sir. Liquid level sensor test and replenish is complete. No problems. Copy that. And that's 0490. Copy. Thank you. OTC, TPE 212. Go ahead, TPE. Yeah, request to speak to CPVD over on his net 173. Or I'm sorry, 175. 172, I believe. PVD OTC. Right, I'm having trouble reading. 172. CPVD OTC. CPVD here? Yes, sir. Can you go over to 172 and talk to TPE, please? Will do.
This is Shuttle Launch Control at T-minus 2 hours, 20 minutes, and counting. The sound suppression water tank on the pad is topped off if necessary at this point. That tank holds 300,000 gallons of water, but is emptied within 20 seconds as the water flows through the sound suppression system onto the mobile launcher deck, sprays through the engine exhaust at a rate of 1 million gallons a minute. The water prevents damage to the orbiter, which could be caused by the magnitude of the sound energy coming from the main engines and the solid rocket boosters at liftoff. NASA Launch and Landing Director Chuck Henschel has also conducted a communications check with the convoy commanders at the Kennedy Space Center, the SRB recovery ships, and on the overseas TAL sites, and he asked for a status of the landing aids such as runway lights, microwave beam, scanning beam landing system, tactical air navigation system, the PAPI and ball bar tracking system antenna, which transmits and receives communications from the launch vehicle, has also been aligned. The telemetry system used for transmitting data and information is being verified at the present time to be operating properly.
And good morning.
The helium tanks in the main propulsion system have completed their pressurization process, which started a half hour or more ago. And Commander Dave Walker beginning to check his comm on board the orbiter. We expect Ron Graby, the pilot, to enter into the orbiter shortly. The countdown going smoothly at T-minus 2 hours, 18 minutes, 3 seconds in counting. This is Shuttle Launch Control.
NTD, CDR, air to ground 1, how do you read? CDR, NTD, read you 5 by. Houston, Atlantis, how do you read CDR?
Atlantis, CDR, this is Houston. You're loud and clear. Good morning, Dave.
Good morning, Frank, and it's beautiful here.
Looks great.
CNSC, OTC. OTC is CNSC. Yes, sir. Step 445, calcite tack and thumb wheel setting is still 118 X-ray. I copy that. Therefore, step 446 will be not performed. Copy.
Out in the White Room, this is Shuttle Launch Control at T-minus 2 hours, 11 minutes and counting. Out in the White Room on the pad, Mission Specialist 3 Mary Cleve is in the process of putting on her emergency equipment prior to her ingress into the orbiter. Dr. Cleve has a degree in biological science from Colorado State University, a Master of Science degree in microbial ecology, and a doctorate in civil and environmental engineering from Utah State University. She's also experienced in space flight, having served as a mission specialist on STS-31B in November of 1985. On this flight, she's going to be responsible for orchestration of secondary payloads and act as the photographer. She's going to be carrying some extra 70mm film and do some polarization work, trying to look at environmental concerns and geography. One of the things that her work will be looking at is that scientists don't quite understand yet what looks clean and what looks dirty when you're looking down from space. And sometimes when you take a look at the ground truth, you find out that that's not, things are not as they appear. Dr. Cleve also will be working with the lightning experiment, although some of that could well happen while the crew is asleep. Prior to joining NASA's astronaut program in May 1980, Dr. Cleve held graduate research psychologist, and research engineer assignments in the Ecology Center and the Utah Water Research Laboratory at Utah State University from September 1971 to June 1980. Her work included research on the productivity of the algal component of cold desert soil crust in the Great Basin Desert, the conditions necessary to maintain certain game fish, and the effects of increased salinity and oil shale leachates on freshwater plankton. The flight controllers in Houston have been talking to the people in the Launch Control Center about whether or not any reprogramming of the loads portion of the computers on board Atlantis will be necessary. At this point, that will not be done in the near future. Balloon data continuing to come back and be analyzed to ensure that there will be no loads that are more than necessary as the flights go through the atmosphere, or that would be a problem as far as the structure of the orbiter. The weather here at the Kennedy Space Center continues to be good. The only concern here is with the crosswinds, and the wind is expected to shift as we go through the countdown, with a sea breeze becoming the predominant force between 2 o'clock and 3 o'clock Eastern Daylight Time this afternoon. If we were to have to launch at the present time, they would have to look very, very closely at the crosswinds at the shuttle landing facility to ensure that those were not more than they would like to see. The countdown clock at T-minus 2 hours, 6 minutes, 40 seconds and counting. This is Shuttle Launch Control.
OTC PLT, how do you read airgram 1? Read you loud and clear on air to ground 1 PLT. How me? Roger, OTC, you're loud and clear as well. Copy that. Good morning, sir. Good morning. Beautiful day. Yes, it is. And ask OTC, just let me know when you're ready for our post-ingress reconfigure. Ask Wilco. NTD, PLT, good morning. Ready to check airgram 1. PLT, NTD, I read you 5-by. Houston, radio check PLT, how do you read?
Atlantis PLT, this is Houston. You're loud and clear. Good morning, Ron.
Good morning, Frank. You're loud and clear as well. OTC, TP. Go ahead. Yes, sir. I would like to speak to CMPS on 168. Okay. MPS, OTC. MPS, I copied. Okay.
OTC CGLS on 212.
Go ahead, GLS.
Yes, sir. Completed implementation of SAT 92. That's step 370 through 377.
Copy that. Thank you.
Yes, sir. And we'd like to go to begin our GLS initialization. That's kickoff step 491, and we will need a quality on 183. And we will need to read the message. SET dual interrupt notification will be activated momentarily.
Okay, copy that. OTC, CBSE, OAS 212. Stand by 1. Okay, GLS, you have a go on 491. CMQC, OTC. And what channel do you need CMQC on?
183.
Okay. CMQC copies. Thank you.
This is Shuttle Launch Control at T-minus 2 hours, 2 minutes, 8 seconds and counting. And Mission Specialist Mark Lee in the White Room outside the orbiter Atlantis now, preparing for his ingress into the orbiter. Mark Lee is the only rookie on this flight. He's a major in the U.S. Air Force, and he was selected for the NASA astronaut program in May 1984. He's a graduate of the Air Force Academy, and he earned a master's degree in mechanical engineering from MIT in 1980. Lee took his pilot training at Laughlin Air Force Base, Texas, and spent 2.5 years flying F-4s at Okinawa Air Base in Japan. While studying at MIT, he specialized in graphite epoxy advanced composite materials.
0507,
While he's been with NASA, Lee has taken part in planning and simulation of several EVA missions, and he served as a support crew member for Mission 51I, LESAT retrieval and repair, and he also served as Capcom in the Mission Control Center. You'll notice in the case of the mission specialists that they will be putting on their launch and entry helmets, and then a nylon twill cover will be placed over the face shield to ensure that it will not be scratched as they move around the cabin to get settled. The support astronaut Bruce Melnick or his backup Blaine Hammond would remove the covers before they leave the cabin. Each of those helmets contain a microphone, earphones, and connectors for plugging into the orbiter control panels. And the helmets provide protection from the crew members' heads and faces, reduce light and sound level in the crew compartment, and provide better communications by cutting down on the level of noise during launch and directing the crew voices into the microphones. Each crew member is attached to an emergency oxygen system, which is used in case of a failure of the cabin system to provide clean air or after landing if there are any hazardous gases around the orbiter.
Commander, pilot ingress complete, ready for post-ingress switch reconfig.
Copy that.
We have just passed the 2-hour point in the countdown. Actually, that would, at that point, we were 2 hours and 40 minutes away from, or 50 minutes away from launch. Launch scheduled for 2:24 p.m. This afternoon, a 23-minute launch window. Everything has been going very smoothly in the countdown. From a weather standpoint, the only problems or concerns they're looking at, actually not a problem at this point, is the crosswinds at Ben Guerir, Morocco, which is one of the 3 transoceanic abort sites. The weather at Morone has some cloud cover, so Ben Guerir would be the prime site as usual, although Morone is used as a weather alternate. Banjul in the Gambia is satisfactory there, but that is only used in the case of some very specific circumstances that would require an in-plane landing.
Assisting RCS drivers on your call.
Right at the moment, the launch team here talking about contingency-type procedures which they would have to implement if there were a loss of the communication between the Launch Control Center and the orbiter. This is something that's very unlikely to occur, but something that they take a look at to ensure that they're able to safe the vehicle if that should be necessary. Called the Launch Data Bus. The information from the Launch Control Center to the orbiter is carried on actually a copper wire system with computer talking to computer, and is the primary means of which the countdown is carried on in getting the proper configuration of the orbiter, and then is used in the safing project should the countdown be stopped for one reason or another. But at the present time, it appears that everything is going very well in the countdown. The ground launch sequencer computer program has been started in the integration console here in the firing room. Engineers now setting up the specific tables in the launch processing system that the ground launch sequencer will use as its guidelines to either let the countdown continue or call an automatic hold when it assumes control of the countdown at the T-minus 9-minute mark.
Copy.
The status of the solid rocket booster retrieval area, as reported to the landing and recovery director, is favorable. The two SRB recovery ships, Liberty Star and Freedom Star, left port yesterday, and it takes them about 12 hours to reach the recovery station. Once on station, they patrol the predicted impact area to chase out any ships that might be in danger of being struck by a jettisoned SRB. The countdown at T-minus 1 hour, 55 minutes, 57 seconds, and counting. This is Shuttle Launch Control.
Good.
And OCT asks, we're waiting for the continuation of the switch reconfig on the GPC-5.
Yes, sir. Copy that. I'm waiting on COFC to perform his steps.
And OTC asks, I'd like to go ahead and proceed then with a caution and warning volume adjust if I could while we're waiting on that GPC step.
Okay, copy that, sir. And OTC to COFC 212. Go ahead.
Step 438 and 439 are complete. I'll verify the OMRS. Verify 440 and 441 are also complete at this time.
Okay, I copy that. Ask OTC.
Go ahead.
Okay, we can go ahead and finish now, sir. Panel 06.
Go ahead.
GPC-5 output switch. Back up.
Complete.
Copy that, and that completes our post-ingress switch reconfiguration.
Roger, I'll be proceeding with the CW volume adjust.
Copy. TPE OTC. TPE, go ahead. Yes, sir. Step 451. Terminate the any-change switch scan monitor program. STP-05.
Will tell.
And CMQC OTC.
CMQC.
Okay, 446, 47, 48, 49 are not performed. I copy. And ISL OTC.
This is ISL.
Okay, you did copy as proceeding with this caution and warning volume adjust.
Affirmative.
OTC asp, caution warning adjust is complete.
Okay, copy that, sir. And ASP OTC.
Go ahead.
Yes, sir. I'd just like you to verify that all the guards are off both the drive and the engine valve switches.
That's affirmed. All guards have been removed.
Copy that. Thank you.
OTC, CGSS.
Go ahead.
Yeah, I'd like permission to kick off step 498, 499.
You have a go, sir.
CGSS, the OAA accumulated force charge is complete.
Copy that, thank you. CMQC, that's 498, 99, and 500. Copy. CDFS, OTC.
Go ahead.
Yes, sir. Going to need you over on 232 for a launch polynomial update.
Okay, copy.
This is Shuttle Launch Control at T-minus 1 hour, 50 minutes, and counting. Everything continuing to go smoothly here in the firing room at the Kennedy Space Center. The simulation of the first motion of the shuttle has been sent to the Johnson Space Center. Range safety and firing room assist in the testing of this system, which indicates liftoff. This signal also starts the clock, which keeps track of the mission time. Heaters in the solid rocket booster hydraulics control systems have also been turned on. They will be used to start the decomposition of the hydrazine fuel, which is used to turn the turbines, supplying power to the hydraulic pumps, which in turn allow the huge nozzles to be moved for steering purposes during the flight. We have just heard that as a result of the latest weather balloons, that we'll be using what's known as the alternate eye load program. This is the program which really tells the orbiter how to steer during its ascent to avoid any loads on the orbiter which exceed what is allowed. The countdown clock continuing at T-minus 1 hour, 48 minutes, 36 seconds in counting. This is Shuttle Launch Control.
Listen, NPD, I read you 5 by. How many?
Loud and clear.
Have a good trip.
Thank you, sir. Houston, this is MS3 Airgun Run. How do you read?
Atlantis MS3, this is Houston. You're loud and clear. Good morning, Mary.
Morning.
This is Shuttle Launch Control at T-minus 1 hour, 47 minutes, 24 seconds and counting. Mission Specialist Dr. Norm Thagard in the process of putting on his emergency equipment prior to getting into the orbiter. A medical doctor, Dr. Thagard, is making his 3rd flight aboard the shuttle on this mission. And he's living proof of the ability of people to change careers and succeed. He originally earned bachelor and master degrees from the Florida State University in engineering science. In 1966, he entered on active duty with the U.S. Marine Corps Reserve. He attained the rank of captain and qualified as a naval aviator in 1968. He flew 163 combat missions in Vietnam before returning to college in 1971 to pursue additional studies in electrical engineering and a degree in medicine. Prior to joining NASA, he was interning at the Department of Internal Medicine at the Medical University of South Carolina. Dr. Thagard served as a mission specialist on STS-30. During that flight, he conducted several medical experiments and collected data on physiological changes associated with astronaut adaptation to space. He also served as a mission specialist on 51B. In addition to deployment of the NewSat satellite, the crew also took care of 24 rats and 2 squirrel monkeys contained in the animal holding facility. Other duties included operation of the geophysical fluid flow cell and the ionization states of solar and galactic cosmic ray heavy nuclei experiment. Mission Specialist Mary Cleve was just completing the first part of her communication checks prior to Dr. Thagard starting to get ready. He will be entering the orbiter shortly and settling into his seat. We expect that the flight crew will have completed most of their entry procedures in another 10-15 minutes. The seat heights have been adjusted and the rudder and hand controls for Commander Dave Walker and pilot Ron Graby. As soon as they completed those entry tasks, they began some of their communication checks, and you'll be hearing a lot more of those communication checks between the orbiter Atlantis, the firing room, and mission control in Houston. The countdown proceeding at T-minus 1 hour, 44 minutes, 20 seconds in counting. This is Shuttle Launch Control.
OTC, OVCC.
Go ahead, OVCC.
Yes, sir. I'd like to have CMQC come up on channel 142.
CMQC, OTC.
CMQC, I copy.
Thank you.
OTC, MS1 radio check.
I read you loud and clear, MS1. How me?
Have you loud and clear also.
Copy that. Good morning.
NTD, MS1, air to ground 1. How do you read?
This NTD, I read you 5, by MS1. How me?
Have you loud and clear also. Good morning.
Good morning, sir.
Houston, Atlantis, MS1. How do you read?
Atlantis MS1, this is Houston. You're loud and clear. Good morning, Mark.
Hey, Frank.
CGLS OTC.
Go ahead.
You call.
Yes, sir. I wanted to report that GLS initialization has been completed at step 491.
Copy that. Thank you.
Firing room 1, this is firing room 2.
OTC to all personnel on 212. Verify all systems ready for crew module closeout.
CGLS 212.
Go ahead, GLS.
Sir, steps 493, 494, and 495 are completed this time, and I have the fill-ins on step 493 when you're ready.
Okay, sir.
Okay, for timer number 1, you have 1 hour, 4 minutes, 0 seconds. Timer number 2 is 7 minutes, 0 seconds. Timer number 4 is 0 minutes, 31 seconds.
Copy that.
Thank you.
OTC, C1. Go ahead. Verify step 526. Copy that. Thank you.
OTC, MS2, air to ground 1. How do you read over?
Read you loud and clear, sir, on air to ground 1. How me?
And you're the same.
Copy that. Good afternoon, sir.
NTD, MS2, air to ground 1. How do you read over?
I read you 5 by, sir. How me?
And you're the same. Good morning.
Good morning.
Houston, MS2, air to ground 1. How do you read over?
Atlantis MS2, this is Houston. You're loud and clear. Good afternoon, Norm.
Good afternoon.
CDR OTC. CDR OTC, air to ground 1.
And OTC ASP, you can go ahead and proceed with the MZC air to ground checks.
Okay, copy that. CDR OTC, air to ground 1.
OTC, CDR.
Yes, sir. Can you verify flight crew is ready to proceed with contact?
This is Shuttle Launch Control at T-minus 1 hour, 30 minutes and counting.
And
The booster test conductor is just being directed to perform a calibration of the solid rocket booster's chamber pressure transducers. These transducers measure the pressure in the thrust chamber at the nozzle, and this information is used to tell the computer when to separate the solid rocket motors. The separation procedure begins when the chamber pressure falls below 50% of normal. This is about 2 minutes and a couple of seconds into the flight. The booster engineer will also be going through a test of the rate gyro assemblies, during which they simulate the effects of flight as far as the rate gyro is concerned with a magnetic field, and then measure whether or not it is reading properly. Everything has been going very smoothly. You've been hearing some of the communication checks between the crew. The nomenclature which is used is, of course, commander is Dave Walker, pilot is Ron Graby. MS1 stands for Mission Specialist 1, and that's Mark Lee. MS2 stands for Mission Specialist 2, that's Norm Thagard. And MS3, Mission Specialist 3, Mary Cleave. Everything going smoothly here as we proceed towards an on-time liftoff at 2:24 p.m. Eastern Daylight Time this afternoon. The countdown clock at T-minus 1 hour, 28 minutes, 18 seconds and counting. This is Shuttle Launch Control.
Close the hatch. Copy that, sir. Flight crew, this OTC UHF. How do you read?
PLT, loud and clear.
MS1, loud and clear. MS2, loud and clear.
MS3, loud and clear.
Copy that. And that completes our comm checks. Thank you.
OTC, CCSE.
Go ahead.
Yeah, could you have the crew verify they have air to ground 1 on at this time, please?
Copy that. Flight crew, OTC. Air to ground 1, how do you read? Loud and clear, air to ground 1. Copy that. Comm checks are complete. And OTC to all personnel, Astrocom voice checks are complete. Channel 212 is available for normal use. OTC, CDPS. Go ahead.
Could I get a CMQC on 152 to set up for our GMT and MET adjust?
CMQC, OTC. CMQC. 152 with TPS, please. Copy. Thank you.
Atlantis, Houston, CDR and PLT configure for air to ground 1 voice check.
CDR, will go.
Atlantis, CDR, Houston, how do you read on air to ground 1?
Houston, Atlanta, CDR. Loud and clear, air to ground 1. PLT has you loud and clear on air to ground 1.
Roger, PLT, you're loud and clear. Configure for air to ground 2 voice check. Atlanta, CDR, this is Houston on air to ground 2, how do you read?
Houston, Atlanta, CDR. Loud and clear.
You're loud and clear also, PLT?
PLT has you loud and clear.
And you're loud and clear also. Configure for comm check on air to air.
Yes, I understand that. We'll give you
Will go.
Yeah, could I take control of camera 171 for about 5 minutes to look at something?
Wait a minute. Can't you just
Atlanta,
bring up,
CDR, this is Houston on air to air, how do you read?
Or what view do you want to look at?
Houston, Atlanta, CDR. Loud and clear.
Camera... Well,
CDR, you're loud and clear also, and PLT, how do you read?
Just looks all funny.
PLT has you loud and clear.
You're loud and clear also. Let's configure for the SIMO voice check, all crew members.
That camera's not used by some other system. CGMC? Go ahead, CNC.
Yes, sir. If I could get a CMQC on 141, please, and your go-ahead to kick off step 593 and 94 per the clock.
Okay, CMQC, OTC 212. CMQC. Right, could we get support on channel 141, please? Copy.
Atlanta, CDR, Houston, how do you read SIMO?
Houston, Atlanta, CDR. Loud and clear, Simon.
You're loud and clear also. PLT, how do you read?
PLT has you loud and clear, Simon.
You're loud and clear also. MS1, Houston, how do you read?
Have you loud and clear.
You're loud and clear also. Maggot, MS2, how do you read?
Houston, MS2 has you loud and clear.
You're loud and clear also. And MS3, how do you read?
Houston, MS3, loud and clear.
You're loud and clear also. SIMO voice checks complete.
CDPS, OTC 212.
This is DPS, go ahead.
Okay, you ready to do the GMT med adjustment?
Yeah, we'll go ahead and do that.
Okay, you have a go at this time.
Okay.
All right, CMQC, that's step 589. And CWS, OTC.
Go ahead.
That camera you're talking about belongs to main engine people. I'm not too sure you can get it at this time. Did you have a problem that you wanted to look at, or?
Only wanted to borrow it for about 5 minutes. OTC to SNA, we concur with that.
Okay. All right, CWS, we'll give you a go at this point and then return it to its original OTC, air to ground 1. OTC, PLT, I'll be moving my seat a little bit in the next minute. Okay, copy that. EPD, OTC. Go ahead. Yeah, PLT is going to be adjusting his seat. Okay. ASP OTC, air to ground 1. Home CSA, SSE. Camera 135. Affirmative. ASP OTC, air to ground 1. OVCC, OTC, 212.
Good, is OBCC?
Yeah, Ken seems to raise the ASP on air to ground 1. Is he still on?
That's negative. He's out of the ship, sir.
Say again?
He is out of the ship.
Oh. Need to verify he was ready for hatch closure.
I copy. Stand by. OTC, CDPS.
Yeah, go ahead, DPS.
Okay, for step 590, our GMT delta was 1 millisecond. GMT adjustment was performed. MET delta is equal to 0 milliseconds. MET adjustment was not performed.
Okay, copy that.
OTC, ask up 212.
Yes, need to verify you're ready for hatch closure at this time.
Ask at the front.
Copy, LVCC, OTC.
Go ahead, is OBCC?
Okay, you have a go to close and latch the hatch for flight per orbiter operation support setup 20.
OBCC, copy.
And OTC, CDPS.
Go ahead, DPS.
GMT and MET adjustments complete, ready for IMU at det and pre-flight align.
Okay, copy that. CGNC, OTC.
Go ahead.
Okay, your IMUS PAPAS program, is that by the clock?
That is correct.
Okay, you have a go at this time to pick it up at 1 hour 10.
Thank you. OTC, Citadel S.
Go ahead, Double S.
Yeah, what we're looking at...
This is Shuttle Launch Control at T-minus 1 hour, 15 minutes and counting. At the shuttle landing facility 4 miles west of the pad, the convoy which would support the shuttle orbiter, should it have to return to the landing facility at KSC, is being positioned to support that contingency. A convoy made up of a number of vehicles, including a purge truck, which flows air through the vehicle to ensure there's no buildup of toxic gases, a cooling vehicle, which provides freon for the orbiter's coolant system to reject heat produced by the electronic and other systems. There's a special white room truck and stair truck that's used for the astronauts to exit the vehicle. And then personnel wearing special self-contained breathing suits called scape suits, who would be the first convoy personnel on the scene in case of a landing.
Go ahead.
At this point, the workers are preparing for positioning those vehicles in case of an emergency. Up in the white room, the go was given for the closeout of the crew cabin, and the door has been closed, and the team up there is in the process of completing the locking of the door and putting in plugs of insulating material to seal it against any possible heat that might seep in during its either ascent or its descent back through the atmosphere. Everything has been going very smoothly in the preparations for this launch. We have just been notified that the pre-flight calibration of the inertial measurement units, which started back at the 5-hour mark, has been completed. And the systems engineer at the Guidance, Navigation, and Control Console reports he's ready to proceed with the IMU attitude determination. He would do that as soon as Greenwich Mean Time, or GMT, adjustment is complete. The mission timer can show either Greenwich Mean Time or mission elapsed time and can be adjusted to within 1 millionth of a second. either by ground command via uplink through the onboard computer or by the flight crew through use of their flight deck display and control panel keyboard. The inertial measurement units are used to tell the guidance systems on the orbiter where it is in relationship to its launch pad here at Kennedy Space Center. Each IMU contains 2 accelerometers to sense accelerations of the vehicle and 2 gyroscopes to provide a stabilized 4 gimbal platform to provide attitude and velocity information with respect to known coordinates. The countdown continuing at T-minus 1 hour, 11 minutes, 42 seconds and counting. This is Shuttle Launch Control.
I'm direct. OTC, OVCC.
Go ahead, OVCC.
Okay, continuity and seal leak checks were complete and satisfactory.
Copy that. OVCC, OTC.
Go ahead, OTC.
And is that complete op support setup 20?
That's a negative, sir.
Copy.
OTC, CCL 212.
Go ahead.
Have CMQC come to 143 to get ready for the cabin leak check.
CMQC, OTC.
CMQC.
Need someone on 143, please.
Copy. CWS, OTC 212. Right. Could you give me an ID on the thruster where that spot is located?
Yeah, the thruster is L1U.
L1U. Copy.
CCME, CSME, OTC.
CCME. SME.
Yeah, are you ready for 610?
That's firm.
That's firm. Copy.
OTC, OVCC.
Go ahead, OVCC.
Okay, I didn't know if you copied or not, but we're ready to do a cabin pressurization.
Copy that. OVCC, OTC.
This is Shuttle Launch Control at T-minus 1 hour, 5 minutes and counting. The closeout crew has completed most of the work now on closing the cabin hatch, and Commander Dave Walker will be closing the cabin vents and the cabin slowly pressurized from its normal sea level pressure of 14.7 pounds per square inch up to 16.7 pounds per square inch. As the pressure increases, the environmental control engineer in the firing room will monitor the status of the test. The higher than normal pressure will cause alarms in the cabin to go off, and this also serves as a test of the orbiter's caution and warning system. Additional cabin leak checks will be performed later in the countdown. The Eastern Test Range safety hold fire checks also have begun, and this test verifies the ability of the range safety officer to stop the countdown during the last few minutes. Everything going smoothly here as the countdown proceeds at T-minus 1 hour, 3 minutes, 50 seconds and counting. This is Shuttle Launch Control.
Thank you. ECL, OTC.
CCL.
Okay, you ready to go, sir?
Yes, sir.
Copy that. CDR, OTC, Area Ground 1.
CDR, go.
Yes, sir. Stand by to perform cabin leak check. And I need you to go to panel L2A1.
On there.
Okay, cabin vent isolation switch open until vent isolation talkback is open and vent talkback is closed.
Then what?
OTC, CMQC.
Stand by, please.
Okay, OTC, CDR, the cabin vent ISO is open, the vent talkback is checked closed.
Copy that. Thank you, sir. Okay, and ECL 601 is complete.
I copy. And we can verify talk back on 602.
Copy. CMTC OTC.
Yes, sir. Orbiter off set up too. It cannot be verified at this time.
Okay. Part B cannot be verified?
That's affirmative.
Okay, ECL will stand by right there for a minute.
I got it.
Okay, CMTC, what do you have open there, sir?
Let me check through it here and I'll make sure.
Okay.
I show page 336 open. The bottom portion there where it says Part B orbiter configuration for launch.
All right, stand by one.
And the stamps I had on the other pages have been voided.
Okay, that is 336 and what volume?
Okay, that's SIS-7 Volume 1, where there's steps sequence 8, 9, 10, and steps 9, 10, 11, and 12.
OTC is ECL 212.
Go ahead, ECL.
Yes, sir. We're in a little bit of a time problem here with getting ready on our 2 PSID leak check. We'd like to get started on that if we could, while you clean up the paperwork.
Okay, stand by one. CMTC OTC.
Go ahead.
Okay, we just completed closing the hatch for flight. So really what we're looking at is step 9, which is door 45. Is that correct?
This is Shuttle Launch Control at T-minus 1 hour and counting.
Okay.
That means that we're 1 hour and 50 minutes away from the launch of STS-30 and the flight of Magellan, the return of the U.S. to interplanetary exploration. The pre-flight alignment of the inertial measurement units was started about 1 minute ago. The pre-flight alignment will be completed during the hold at T-minus 20 minutes.
It was Victor 80, 94500.
The pre-flight alignment cannot be completed more than 10 minutes prior to the computer transition to what is known as Op 1. This occurs when the team comes out of the T-minus 20-minute hold. However, if it's delayed longer than 10 minutes allowed, then the pre-flight alignment must be performed again.
Copy that. And if you would...
The solid motor rocket chamber pressure tests began about 30 minutes ago, and they have been completed. And safety officials have confirmed that fire and rescue personnel will be stationed at the shuttle landing facility and just outside the blast danger area by the T-minus 30-minute point. The landing and recovery director, Chuck Henschel, has confirmed that we're getting good data from the navigation transmitters and the microwave scanning beam landing system at the shuttle landing facility. These navigational aids would only come into use in event of a return to launch site abort. The countdown continuing at T-minus 58 minutes, 25 seconds and counting. This is Shuttle Launch Control.
OTC, CCME.
Go ahead.
Yes, steps 611 through 613 are complete.
Copy that.
OTC is ECL 212.
Go ahead.
Request that CDR give us the reading off of panel 01 on the cabin pressure.
CDR OTC.
CDR go.
Yes, sir. ECL's requested a reading off panel R1 on the cabin pressure.
Okay, 14.8 to 14.9, looks like not quite 15.
You copy ECL?
That was 15.
14.8, 14.9.
Not quite 15.
Copy that.
Thank you, CDR.
And also, TC, if CDR could let us know, give us a mark on that master alarm while we're pressurizing.
Okay, CDR, you copy?
CDR, Wilco, I'll let you know when I hear the master alarm.
Thank you, sir. GNC OTC.
Go ahead.
Yes, sir. Did you complete 593.94 yet?
593 is in work, 594 is complete.
Okay, copy that. Then I'll give you a go to pick up with 605 when you're ready.
Copy. OTC ECL 212.
Go ahead, ECL.
Yeah, we've got a violation here on the LCC, page 6.8.1-05.
Okay, that was 6.8.1-05.
That's correct.
Okay, standby 1, TPE, OTC.
Yeah, TPE is William.
Okay.
Okay, what we've got is a no response on the cabin pressure sensor here doing pressurization. We are getting an increase in pressure in the airlock differential, and the LCC states a 1 of 2. So we're really not violating the LCC, but we do have a failed measurement there. CCL TPE, what's the FD? Okay, the FD number is Victor 61 P2405A. Presently reading, what, 14.5? It's reading 14.58, and it's acting like the sense port is not picking up the changes there. It's either capped or there's some blockage there. It's stuck at 14.58.
This is Shuttle Launch Control at T-minus 50 minutes and counting. The range safety officer has begun a final network verification test of the range safety command network. The terminal countdown range safety closed loop check will be performed at a T-minus 45-minute point. During the performance of the cabin leak check, they do have a sensor problem, but it is not a problem as far as the flight is concerned. You'll be hearing pilot Ron Gray be asked by the orbiter test conductor to configure switches in the cockpit to pre-activate the water spray boilers. The orbiter has 3 spray boilers, 1 for each hydraulic system, and their job is to cool down hydraulic fluid and APU lube oil, and then vent the steam which results overboard. During the boost phase, orbital checkout, deorbit, and entry through landing, the spray boilers are activated if the hydraulic fluid temperature exceeds 208 degrees Fahrenheit and the lube oil exceeds 250 degrees Fahrenheit. The spray boilers are located in the orbiter's aft fuselage, and each weighs about 181 pounds when empty. They hold about 120 pounds of water, and when the APU hydraulic units are activated at T-minus 5 minutes and the fluid temperature rise, spraying will be initiated as required. The launch team has been looking at, through the television cameras on the pad, at what they think is a small stain near one of the OMS pods. They have determined that that is not a problem, but have had a discussion about whether it could be a slight indentation into a thermal tile or not. It's been determined now that that's a stain and that no problem exists there. The countdown continuing at the T-minus 47 minutes 40-second point in the count. This is Shuttle Launch Control.
OTC is ECL. Go ahead. Yeah, we'd like to go ahead and take an IPR on this problem here.
Copy that. ECL OTC.
Go ahead.
Okay, you want to go on over to 232 and you can give that directly to the NTD and get your number there.
I copy that, going to 232.
Copy.
OTC, TPE.
Go ahead.
Yeah, we need to go ahead and pick up that IPR now.
Okay, yeah, I sent ECL over to 232 to go ahead and give the NTD a description and pick it up.
GLSN 212.
Go ahead.
Yes, sir. I'd like to know if I have a go per the clock for step 672.
Yes, you have a go for 672 per the clock.
I copy. Thank you.
OTC CNSC 212. Go ahead. Could we get ECL to come over and talk to us on 173?
Yeah, momentarily. ECL OTC.
This is OTC 212.
Yeah, ECL, can you go over to 173, please?
Okay.
OTC GLSN 212.
Go ahead, GLS.
Yes, sir. Steps 673 through 678 are complete with a not perform on 675.
Copy that. Thank you.
OTC, CDPS.
Go ahead, DPS.
683, 684 complete.
Copy.
Sorry, I missed it.
CGNC OTC.
Go ahead.
Yes, sir. Are we complete on 593?
Affirmative.
Okay, and how about 605?
605 is in work.
Copy.
OTC CMQC.
Go ahead.
Add constraint line item 171 at step 16, 1025.
Got it. Thank you, sir.
OTC TBC 212.
Go ahead, TBC.
Okay, per 689, orbit SRB, LDB, redundancy check complete.
Copy that. CCSE, RCRE, OTC.
RCRE, go.
CCSE, go.
Can you support S-band at high power on 232, please?
Copy that. And OTC, CCSE.
Go.
Would you notify DSWF that we will be changing frequencies here?
This is Shuttle Launch Control at T-minus 40 minutes and counting. The terminal count range safety closed loop check, which is underway, verifies that the shuttle's range safety receiver responds correctly to commands sent from the ground support equipment located in the mobile launch platform using the actual flight code. Inhibits are placed in the system to prevent inadvertent firing of the range safety devices during this test. Once the check is complete, the range safety carrier is turned back on and the safe and arm device is configured to the safe position. At the present time, discussion going on the loop about a pressure transducer that measures the cabin pressure. There are two such transducers in the cabin to determine whether or not the cabin pressure is going up, down, or staying the same. One of those does not appear to be working at the present time. Discussion going on as to what, if anything, needs to be done about that at the present time. It does not appear to be violating a launch commit criteria. The NASA test director, Ron Phelps, has asked the Mission Control Center in Houston to switch the Discovery's S-band antennas to the high-power mode, and also to configure the communication system so at liftoff it will transmit and receive by radio rather than through hard wires as is done during the countdown. The ground launch sequencer mainline computer program has been activated and is now actually processing data. This program will monitor various key commands and systems prior to its assuming control of the countdown at the T-minus 9-minute mark. At this point, we are moving towards a 2:24 p.m. Eastern Daylight Time liftoff, 23-minute window for Magellan, which is determined, the opening of that window determined by the ability, the amount of propellant and energy carried by the shuttle to get into the right orbital plane in relationship to Venus, and the end of that window determined by the time that it becomes dark at the transoceanic abort site. The countdown clock at T-minus 37 minutes, 30 seconds, and counting. This is Shuttle Launch Control.
Yeah, we're going ahead and we've got the cabin pressurized. We're going to remove the probe at this time and install the flight cap. You'll be getting a klaxon alarm from the flow coming out of the crew module causing the DPDT to alarm.
Okay, I copy that. CDR, you copy?
Yeah, run that by me one more time, please, OTC.
ECL?
Yeah, go ahead.
Yeah, could you repeat that for CDR, please?
Just to let you know, CDR, you're going to be getting a klaxon alarm as soon as we remove the probe from the hatch due to flow going out of the hatch. The DPDT alarm will cause that.
Okay, we're prepared for that. Say we got the klaxon and we reset it.
CCME OTC.
CCME, go ahead.
Yes, sir. Could you go to channel 128, perform step 668 RF step source verification?
I copy, going to 128.
Thank you.
OTC is ECL 212.
Go ahead, ECL.
I wonder if we could bother CDR to give us a reading off of panel 01 of the cabin pressure.
CDR, OTC.
Yeah, cabin press is still reading 14.8 about. It hasn't changed the whole time.
Copy, ECL.
Yeah, we copy. Thank you. OTC is ECL 212.
Go ahead.
Yeah, we've secured the crew module hatch, and I've given the team a go to continue with Alpha Port 720, configuring a white room for launch.
Okay, copy that. And is that step 679?
It's a negative. Stand by on that.
Copy. CDR OTC, air to ground 1.
CDR, go.
Yes, sir. Can you go ahead and perform your past BFS transfer prep?
That's in work.
And do you agree with us that two LCCs, we're one step away now? Either of the other measures go to. And it may be a camera back.
CDR has executed the past BFS transfer, OTC.
Copy that. Thank you. OTC, CDPS, steps 713 and 714 complete. Copy that.
OTC, CCME.
Go ahead.
718 complete.
Copy.
OTC, CCL 212.
Go ahead.
I can give you step 679 at this time, and we're ready for the cabin vent redundancy configuration.
Copy that. CDR, OTC.
CDR, go.
Okay, sir. Panel L2A1.
On there.
Vent isolation switch close until vent isolation talkback is closed.
This is Shuttle Launch Control at T-minus 29 minutes, 57 seconds, and counting. Commander Dave Walker in the process of performing a test of the transfer capability between the primary ascent computer redundant set and the single backup flight system computer. That's between the four computers which work together and the one backup. This test verifies that critical guidance data can be transferred from the redundant set of four simultaneously operating computers to the single backup, and that the computers can operate in a synchronized manner. Throughout the countdown, the computers talk back and forth to each other, assuring each other that everything is fine and that they all agree with each other. This test is to ensure that in the remote possibility that the four primary computers shut down during ascent, that the single backup computer could take over and flight would continue safely. The leak checks of the cabin have been completed. The orbital maneuvering system gaseous nitrogen tanks have been pressurized for launch at this point. Gaseous nitrogen is used to operate the valves, allowing the hypergolic propellants to flow into the engine. That system will now be ready when the onboard computers command the OMS engines to fire for the first time to put Atlantis into its initial orbit. And the NASA test director has asked that the post-launch inspection and safing teams be asked to report to the assembly area at roadblock A11. For some people, the launch is the end of their task for the day, but once the space vehicle leaves the pad, there's still a lot of work for others. They must make sure all the various propellant systems are drained or otherwise made safe for people to start work and prepare the pad for the next launch.
Copy that.
The countdown clock continuing at T-minus 27 minutes, 55 seconds and counting. This is Shuttle Launch Control.
COSC, LPS, OTC.
COSC, go ahead.
LPS, OTC. LPS, OTC, 212. Okay, COSC, I want to kick you off on step 724, setting up your plotters.
Copy that.
LPS, OTC, 212. COSC, could you see if you could raise LPS there over on 127?
Copy that.
ISL, OTC.
This is ISL?
Yes, sir. Step 739. Will we perform that?
Affirmative. 739 through 742 is complete.
Copy that. Thank you. ISL, OTC.
This is ISL?
Okay. Are you ready for the MEC pre-flight bite check?
Affirmative.
EPD, OTC.
EPD, we've completed 749 and 750. The bite is good. Did it by the clock.
Copy that.
And we'll take non-performs on 752, 53, and 54.
Copy.
OTC, COOS.
Go ahead.
I'd like to verify step 722.
Copy.
This is Shuttle Launch Control at T-minus 25 minutes and counting. A pre-flight test of Atlantis' Master Events Controller has been completed. The Master Events Controllers relay commands from the orbiter's computers to fire explosive charges to separate the tank and twin booster rockets from the orbiter in flight. Ground support equipment has been activated that contains the Pyrotechnic Initiator Controllers, or PICs. These are solid-state devices that arm, fire, and disarm the Space Shuttle pyrotechnic initiators used on the SRB hold-down post. These are explosive bolts that release the solid rocket boosters at the time of ignition. Also, it's been armed for starting the hydrogen burn-off sparklers, the T0 umbilical, and the external tank vent arm release system. The NASA test director is about to verify to safety that the closeout crew rescue locker equipment has been replaced and the lockers secured. The White Room personnel have secured the White Room, and they will be going down to the pad surface in the near future. They are completing the door plugs at the present time, and they have already rolled back some of the steel that's used when that White Room is against the orbiter to prevent any weather conditions from affecting the White Room conditions. The NASA test conductor is asked to be notified when all non-essential personnel have cleared the blast danger area and the roadblocks. A recent weather briefing showed that the weather is still forecast to be go at the time of launch at 2:24 this afternoon. The main concern here at the Kennedy Space Center has been crosswinds at the shuttle landing facility, and the winds are in the process of coming around. They're expected that by shortly after 2 o'clock that they will be from the east-northeast at 10 knots, gusting to 15, and that would be satisfactory. At the present time, they are not at that. They're coming more from a westerly direction, and we are expecting, though, that a sea breeze will kick in at the appropriate time and allow us to go today. The countdown clock at T-minus 22 minutes, 21 seconds and counting. This is shuttle launch control.
Go ahead.
Top support step 20 is complete.
Okay, copy that. That's step 706. Can you verify the ECS air dampers closed?
That's verified.
And chamber ECS air dampers open?
That's verified.
Copy that. Thank you, sir.
Okay, we're looking for a go on your command to break the white room down.
OTC, CDPS.
Go ahead.
Atlantis, Houston.
We need
or
to verify no bugs by item 25 on CRT3.
Stand by 1 DPS.
That's time critical. We need to get that for JLS.
Houston, Atlantis, loud and clear, CDR.
You're loud and clear also. PLT, how do you read?
Houston, Atlantis, PLT has you loud and clear.
You're loud and
This
clear
is
also.
shuttle launch control at T-minus 21 minutes and counting. We're just 1 minute away from the first of two final built-in holds. This one will be a 10-minute one at the T-minus 20-minute point.
MS3, how do you read?
The primary computer guidance data obtained as a result of the inertial measurement unit alignment has been transferred to the backup computer to ensure that both systems have the same information. In case of a prime computer failing during flight, the backup would take over control.
CDR, OTC.
The commander, Dave Walker, and the crew have been directed to begin what are called simul voice checks. This is actually voice communication using two of the channels that are used for communication back to the Mission Control Center and to the Launch Control Center simultaneously. And it's important that there not be an echo on those lines. So one is a backup to the other, and they're run together. T-minus 20 minutes and holding. This is a 10-minute build-in hold. During this period, all computers in the firing room or control room are configured with the proper programs for the final portion of the countdown. When we come out of the hold, Atlantis' onboard computers will transition into what's called the Ops 1 configuration, which is the terminal countdown configuration. Also during this hold, the orbiter's inertial measurement units will complete their pre-flight alignment and will go into the inertial mode to account for the Earth's rotation between now and launch time. The countdown clock holding at T-minus 20 minutes. This is shuttle launch control.
OTC, COFC.
Go ahead.
212. Yeah, I'd like to report steps 0724 complete at this time, and 0725 through 0729 are also complete, and I'd like to report that GNC SCAR spare plotter setup is complete for 7:30.
Copy that.
OTC, CFCT.
Go ahead.
Can we get a CMQC over on 153 for the fuel cell purges?
CMQC, OTC.
CMQC, I copy.
Thank you. OVCC, OTC.
Go ahead, it's OVCC.
Okay, I'd like you to just stand by there till our cabin vent's complete, and then we'll break down.
Say again, please.
I'd like you to stand by till our cabin vent is complete, and then we'll break down.
I copy. We're going to do a tile inspection right now.
Okay, go ahead.
Okay, LTC, TP.
Go ahead.
Yeah, reference tile, the original problem reported by OOS is a known discrepancy.
Copy that. Thank you.
OTC, TP.
Go ahead.
Yeah, let's see, I'd like to speak to CISL over on his net 145.
ISL, OTC.
This is ISL, I copy, 145. OTC, EPD.
Go ahead, EPD.
Yes, sir. Can you send a CMQC to channel 151?
CMQC, OTC.
CMQC.
Need someone on 151 with EPD.
Copy.
ECL, OTC.
CCL, go ahead.
Yeah, how close are we to completing the cabin vent?
Yeah, I can give you step 0770 this time.
Okay, copy that, sir. CDR, OTC, air to ground 1.
CDR, go.
Yes, sir. On panel 01A1, can you report cabin pressure?
Well, we can report it. It's still reading 14.9.
Okay, I copy that. Okay, and ECL step 772.
Yeah, we're reading 15.05.
CDR, OTC.
OTC, CDR, go.
Yes, sir.
This is Shuttle Launch Control at T-minus 20 minutes and holding. We have exactly 4 minutes remaining in this 10-minute build-in hold. The NASA test director has been asking each of the systems engineers to report back on their respective test conductors that the proper programs are running in their consoles and that their systems are operating properly.
OTC, OTC.
NASA Test Director Ron Phelps is about to brief the launch team on recycle options during the remainder of the countdown.
Thank you, sir.
Basically, from now till T-minus 31 seconds, any of the console operators can ask that the countdown be held if a problem is identified. After 31 seconds, however, any unplanned hold would result in an automatic cutoff of the countdown and a recycle to the T-minus 20-minute point. Because of the short launch window today, that would result in scrubbing today's launch. The closeout crew is finishing up their work up on the 195-foot level and the orbiter access arm, tying back the various portions of that weather protection system that fits up against the orbiter. Some of the closeout crew making use of safety devices while they work on that arm. Even though the primary objective of the STS-30 launch is to successfully deploy the Magellan spacecraft, there are several other experiments which will be carried out on orbit. One is called the mesoscale lightning experiment, and this basically takes advantage of the onboard cameras simply to take pictures of thunderstorms as they fly over them at night. They are working on a lightning mapper sensor to fly on a GOES satellite and are hoping to obtain additional information from the shuttle to be used in the development of that mapper sensor. Astronauts on previous flights have reported something called sympathetic lightning, and they want to learn more about this phenomenon. Sympathetic lightning basically is the seeing of one stroke of lightning, then triggering strokes adjacent to it. Some of the scientific objectives of that particular experiment is to measure the horizontal dimensions of the cloud-top lightning emissions. They've been measuring this from aircraft, but they can't see a view taking in hundreds of miles as you can from the orbiter. On STS-29, astronauts took some video footage and to try and determine if one lightning discharge can trigger another in another cloud. And while it doesn't appear to be enough energy to do that, it may nevertheless be happening. Another experiment is the microgravity research fluid experiments apparatus, which is operated by and designed by Rockwell. This is a fluid experiments apparatus and is part of a joint agreement between Rockwell and NASA. The information used in optical glass research, monodispersed latex reactor, crystal growth experiments.
You call?
Yes, sir. The wire room is open
The
now.
work in this
You are departing in
with this device began in the 1980 time frame, about the time that organizations were taking a look at what materials research could be done in space. On this flight, a floating zone crystal growth experiment will be conducted, in which a crystal or non-crystalline material can be melted and then through attaching a small seed crystal, progressively melting along in this case, a wire, see if the material takes on the same structure as the seed crystal. In this way, it may be possible to propagate crystal structure through an entire sample, whereas on the ground, crystals would be very, very small before they completed their growth.
Go ahead. Passes in 101. We're ready to take BFS.
A number of materials are of interest in the industry, such as cadmium, telluride, indium, antimony, gallium telluride, and gallium arsenide.
One for your checklist.
The experiments on board the shuttle begin with low melting point materials. The countdown clock picked up once again at the T-minus 20-minute point, and is proceeding. We're at T-minus 18 minutes, 37 seconds, and counting.
All LDBPM you reach for remainder of countdown.
The purge of the 3 fuel cells is underway to clean the plates of hydrogen molecules which want to stick there and decrease efficiency. This purging is done by flowing hydrogen at a high rate through the cell. The data processing engineer has confirmed that the onboard computers are in the process of making the transition to the terminal countdown configuration.
You have a go, AFM.
Commander Dave Walker in the process of placing the backup flight computer in the same Ops 1 countdown configuration. Just past the T-minus 18-minute point, and Commander Walker has confirmed the backup computer is in the proper operational mode.
PVD, OTC. PVD. Yes, sir. Step 787, 88, and 89, will they be performed? That's affirmative. Copy that. And I'll give you a go on that, sir.
T-minus 17 minutes, 30 seconds, and counting.
OTC, sir. Go ahead. Verify step 796 and 797. Copy that. CBFS, OTC. Go ahead. Yeah, can you verify 793?
Yes, sir, and the RAS number is 030.42. And also I can verify step 921, BFS is ready for uplink.
Copy.
Past the 17-minute point, and Commander Walker reporting that ready for the backup flight computer uplink. Dumping of the Ops 1 program stored in the memory of one of the 4 redundant general-purpose computers has started, and this takes approximately 7 minutes to complete, after which engineers will examine the data for any miscompares. The flight control engineer in the process of checking critical surface driver currents and positions in preparation for hydraulic activation. Hydraulic activation occurs when the auxiliary power units are turned on at T-minus 5 minutes.
I can verify that. 7 p.m. go.
T-minus 16 minutes and counting. The data processing engineer reporting that the backup flight system is in synchronization with the primary system, and the system ready for Houston to transmit their pre-flight uplink command to the backup flight system.
Copy that. CEPP OTC. CEPP OTC 212.
T-minus 15 minutes, 19 seconds and counting.
TV's en route for the prayer monitor.
Copy.
Coming up on the 15-minute point in our countdown. T-minus 15 minutes and counting. Water levels in the water spray coolant boilers are being checked and have been verified to be sufficient for the mission. The cross-feed valves between the orbital maneuvering system and the remote control system are being configured for launch. the orbiter test conductor asking pilot Ron Graby to read out the quantities of propellant in the reaction control system tanks.
Configuring pass and VFS horizontal set.
Copy. Houston flight, OTC.
Coming up on the 14-minute point in our countdown.
Go ahead. May I speak with TPE on my channel 145? TPE, OTC, copy 145. Thank you.
T-minus 14 minutes and counting. During the last minute or so, security has reported to NASA Test Director that all non-essential personnel have cleared the blast danger area. There are only a few people left within the area and are located at forward observer sites.
And flight zone 212.
Purge of water from the onboard fuel cells has been completed. Water is a byproduct of the production of electricity by combining the hydrogen and oxygen in the fuel cells.
Go. Steps 933 through 937 will work per the clock.
Copy.
OTC, CPVD.
Go ahead.
All vent doors are
At the present time, the fuel cell electrical loads are being adjusted to between 250 and 290 amps.
NTDS flight 212.
Roger, you can do your BF pre-flight uplink at this time.
Okay, in.
T-minus 13 minutes and counting.
NTDS DM212. Go ahead. Can we have a go on sequence 160953, sir? Yes, you can deactivate. Copy that, sir. Inward. Okay.
OTC, PLT, horizontal set config complete. Pass and VFS.
Copy that, PLT, and PLT, you can configure the ohms interconnect per your checklist.
PLT, rather.
Go ahead, Frank.
Coming up on the 12-minute point in our countdown.
All is interconnect configured complete.
Everything going smoothly on board. T-minus 12 minutes and counting. We are counting down to the T-minus 9-minute point where we will be holding for 40 minutes. The Landing and Recovery Director, Chuck Henschel, is verifying that all contingency support operations are ready for launch and emergency aircraft and personnel are on station.
PLT, OTC.
T-minus 11 minutes, 30 seconds and counting. The dump of the general purpose computer is completed at this point, and the memory now to be compared with that of a ground-based computer to ensure that there's no unexpected bits of information in it which would cause a problem during the flight.
Copy. OTC, TPE. Go ahead, TPE.
T-minus 11 minutes and counting.
The
flow rate of conditioned air being blown through the orbiter's payload bay has been reduced, and it will be verified to be approximately 170 pounds per minute.
26:58 in that time frame. And again at 17:29:10.
NTD, say again for SPE.
And we're wondering why that happened.
OTC, CPVD.
Go ahead.
That sounds like the time frame when we're reconfiguring vent doors 1 and 2 right-hand side.
Okay, copy. That'll do it. Thanks, sir. Thank you, PVD. NTDSD.
OTC, PLT, MTS, helium reconfig complete.
Copy.
Coming up on the T-minus 10-minute point now. T-minus 10 minutes and counting. Just 1 minute away from entering our final build-in hold for the countdown of STS-30. The status of the vehicle is go at this time, and onboard computer programs have been examined and verified to be the proper one. All aero surfaces and actuators that will steer the vehicle through powered flight are in the proper configuration, and the flight crew has completed their cabin leak checks, communication checks with the launch team and flight controllers at Mission Control.
OTC, CCME. Go ahead. I can give you a 965 and 966. 967 is not performed. Copy.
Coming up on the 9-minute point in our countdown.
OTC, go ahead. 956 is complete. Copy.
T-minus 9 minutes and holding. This is a 40-minute build-in hold, and we'll resume the countdown at 2:15 p.m. Eastern Daylight Time. As we come out of the hold, the ground launch sequencer takes over control, issuing commands for the final critical tasks and monitoring as many as 1,000 different measurements during the final 9 minutes. At this point, all firing room personnel switch to the same communication channels and stay on it through launch. You'll be hearing the mission control update the commander and pilot on the return to launch site abort altitude settings and runway, and they'll put that necessary information into the onboard computer. At the present time, it appears that that would be a landing on runway 15. During this 40-minute hold, the payload people who are monitoring and controlling the Magellan spacecraft will be working a problem which they have, which they believe is based on the high power of the transmitters at Mila, the Merritt Island tracking station. At the present time, they are taking a look at a dropout in some data being received back.
Okay, sir, you've got to go on that.
The primary objective of the STS-30 launch is to successfully deploy the Magellan spacecraft and to place it on an approximately 15-month journey to Venus. It's been 11 years since NASA has launched an interplanetary spacecraft, and the hopes and dreams of many scientists and ordinary people are riding on it. They're also excited because it's the first in a string of spacecraft to be launched during the next few years, which would result in a rich load of new science. The Magellan spacecraft will provide more data than has come back from all of the interplanetary spacecraft launched in the past put together. Scientists may spend as much as 10 years or more studying that information, and it will be followed by Galileo in October to study Jupiter, Space Telescope to allow astronomers to see objects near the edge of the universe and increase the resolution of those closer than that 50 or more times. Cosmic ray observatories and several other great observatories are going to look at the universe in a whole new light that can be shed by creating eyes to see different wavelengths of radiation other than the narrow band seen by our eyes. The Magellan project was conceived and has been managed by the Jet Propulsion Laboratory, which has managed many of the nation's interplanetary probes. The spacecraft was designed and built by Martin Marietta Astronautics Group in Denver, and the primary instrument, the synthetic aperture radar, was built by Hughes Aircraft Company Space and Communications Group. Magellan is designed to do the highest resolution topographical map to date of the surface of Venus using that synthetic aperture radar. Despite its sophistication, Magellan is a patchwork of parts from other spacecraft programs in order to save money. The large antenna was left over from the Voyager program, and the command and data system, which is the brain used to operate the spacecraft, came from the Galileo program. One test article was borrowed from the Voyager backup spacecraft hanging in the Smithsonian. In the interest of economy, the program, which started back in the early 1970s, sacrificed many planned experiments primarily related to learning more about the atmosphere.
Ingress and egress of the firing room will not be allowed after...
At the present time, we are in the T-minus 9-minute hold, a 40-minute hold period to allow time for the management team and the test conductors to discuss any issues that they may have prior to picking up the count once again. Launch scheduled for 2:24 p.m. Eastern Daylight Time, a 23-minute window.
Go ahead, Launch Director.
This is Shuttle Launch Control.
Okay, to make you aware, they are running a special test on the
Copy. And RSO NTD.
Go ahead.
Okay, comm check on 212.
Roger, loud and clear, how many?
Copy you 5 by.
Roger.
And C, HTD, GSS, and JBFX NTD.
CGSS go.
CHTD go. JBFX. Verify active on 212 and monitor 232 for the remainder of the count.
TSS verifies.
CHTD count. Verifies. JPX, copy. OTC CCSC 212.
Go ahead.
What is this special comm test that's going on, please?
Stand by.
This is the NTD. What they're checking is some high power level interference that they're seeing with the Magellan spacecraft. Okay, how will that affect our orbiter communication? It shouldn't bother it. We check with flight, and what they're doing is all transparent to the vehicle at this time. Okay, be advised if there's any uplink level variations, we may lose NSC frame sync. I understand.
This is Shuttle Launch Control. We're at T-minus 9 minutes and holding. At the present time, there's just slightly more than 33 minutes remaining in this build-in hold. The NASA launch director, Bob Seek, has briefed the crew on the problem that is being worked by the spacecraft people. The Magellan spacecraft had a receiver lockup, and it's believed to have been caused or to have occurred when the Mila tracking station went from low power to high power and may have saturated that receiver. The power is going to be reduced to see if that was indeed the problem. However, the director of payload operations here at the Kennedy Space Center just reporting that the test has been completed and that the change to high power by the Mila antenna does cause a lockup of the receiver on board Magellan.
And flight NTD 212. Flight NTD 212.
31 minutes, 30 seconds remaining in this build-in hold. The flight crew heard it reported that the weather appears to be cooperating both here at the Kennedy Space Center and overseas.
NTD flight 212.
Yes, sir.
You called?
Yes.
At the present time, work going on to confirm that the problem with the locked up receiver on Magellan was due to that high power configuration.
And plan on picking that up about L-19.
Okay.
Magellan, in addition to sacrificing some planned experiments because of budgeting, has also sacrificed speed in order to assist the Galileo program. If Magellan could be launched at the proper time in the Earth and Venus orbital relationship, the spacecraft could have zipped over to Venus in 4 months. By giving up the best time for the trip, the Magellan scientists allowed the Galileo scientists to have the best launch period. Galileo, which is planned for launch in the fall, will travel outward to Jupiter by first going to Venus, using the mass of Venus as a slingshot to add energy and velocity to its journey and fling it outward towards Jupiter.
Okay, we are holding off on our...
In the case of Magellan, it will take 15 months by using this window, and all of the ingenuity of the mathematicians and physicists who designed the roadways through the solar system.
Copy that, sir. Copy. Okay, pick it up.
Magellan will be sent into a orbit around the sun, basically. It will cross the orbit of Venus at a time when Venus is not actually there. However, on the return time, when it crosses the orbit of Venus, Venus will be there, and it will have a firing of a motor on board, which will place it in orbit around the planet. Test activities continuing with the Magellan as other tasks in this T-minus 9-minute hold continue as well.
NCD launch director. Go ahead, launch director. Okay, whenever flight is ready, we can do the minus 25-minute weather tag up on 231. Okay, flight, you ready?
NTD stage 20.
NTD flight on 212.
Okay, flight, you ready for your T-minus 25-minute briefing at this time?
No, sir. Give us about 5 minutes.
All right, copy. In about 5 minutes. Go ahead, HYD.
Okay, we have a LCC out of limit here, LCC 6.7.2-06, our boiler 2.
Okay. SPE? SC, okay. You on monitoring here? Yes, sir. Okay.
Well, also our boiler 2, okay. We're below the 133 temperature limit.
Okay, and HYD saying we got a problem here at this time?
No. We had the okay prior to, the criteria is between ET cryo loading and the APU pre-start. We had the okay on. We have lost it at this time. We're below the 133 steam vent temp. The crew should be aware that they won't get an APU okay in the cockpit at T-minus 5 minutes.
NTD SRO on OIS 212. Standby SRO. HYD ST.
HYD.
Okay, on page 672-10, you can confirm that you did have water spray boiler okay during crowd tanking.
That's correct.
Okay, and we can invoke the procedures defined on the page, is that correct?
That's correct.
And you do not have an LCC violation?
That's correct.
Okay, and what does the crew need to be aware of at this time?
Okay. HYD, which water spray boiler was it?
Okay, it's water spray boiler 2. They should be aware that the steam vent, they won't get an okay to, they won't get a ready talk back for the system 2 boiler.
Okay, and TD, when OTC gets PLT to start the APUs, he could just tell him that he may not get a talk back on APU number 2.
Okay, I understand. And OTC, do copy?
OTC copies. And this is an expected condition for where we are in this configuration.
This is Shuttle Launch Control at T-minus 9 minutes and holding. We have 25 minutes Venus at a time when Venus is not actually there. However, on the return time, when it crosses the orbit of Venus, Venus will be there, and it will have a firing of a motor on board, which will place it in orbit around the planet. Test activities continuing with the Magellan as other tasks in this T-minus 9-minute hold continue as well.
NCD launch director. Go ahead, launch director. Okay, whenever flight is ready, we can do the minus 25-minute weather tag up on 231.
Okay, flight, you ready?
NTD stage 20.
NTD flight on 212.
Okay, flight, you ready for your T-minus 25-minute briefing at this time?
No, sir. Give us about 5 minutes.
All right, copy. In about 5 minutes. Go ahead, HYD.
Okay, we have a LCC out of limit here, LCC 6.7.2-06, our boiler 2.
Okay. SPE? SC, okay. You on monitoring here? Yes, sir. Okay.
Yeah, we'll also boiler 2, okay. We're below the 133 temperature limit.
Okay, and HYD saying we got a problem here at this time?
No. We had the okay prior to, the criteria is between ET cryo loading and the APU pre-start. We had the okay on. We have lost it at this time. We're below the 133 steam vent temp. The crew should be aware that they won't get an APU okay at in the cockpit at T-minus 5 minutes.
NTD SRO on OIS 212.
Standby SRO. HYDST.
HYD.
Okay, on page 672-10, you can confirm that you did have water spray boiler okay during crowd tanking.
That's correct.
Okay, and we can invoke the procedures defined on the page, is that correct?
That's correct.
And you do not have an LCC violation?
That's correct.
Okay. Okay, and what does the crew need to be aware of at this time? Okay. HYD, which water spray boiler was it?
Okay, it's water spray boiler 2. They should be aware that the steam vent, they won't get an okay to, they won't get a ready talk back for the system 2 boiler.
Okay, and TD, when OTC gets PLT to start the APUs, he can just tell him that he may not get a talk back on APU number 2. Okay, I understand. And OTC, do copy? OTC copies. And this is an expected condition for where we are in this configuration.
This is shuttle launch control at T-minus 9 minutes and holding. We have 25 minutes and 17 seconds remaining in this build-in hold. The tests that were conducted by the payload team has confirmed that the Magellan spacecraft is ready for launch. There was a problem with a receiver locking up due to the high power condition of the Mila tracking station. However, once that was understood, it was determined that we would be able to launch today.
Number is 30RV 0257.
Okay, and SPE, you copy the launch nerd?
At the completion of its 15-month flight through space, Magellan will approach Venus almost over its north pole. A solid propellant motor will be fired to slow it so that it will be captured in an elliptical orbit by the planet. For 18 days, Magellan will be checked out and then begin a 243 Earth Day mapping mission. That's slightly more than a Venusian year. Each orbit will take about 3 hours, 9 minutes, swinging as close as 155 miles and going out as far as 4,977 miles from the surface. Magellan is a smart spacecraft which can heal itself of many problems, and if it decides it cannot fix something, it puts itself to sleep temporarily to allow controllers on the ground to work out the problem. The orbit is designed so that the radar will gather information during a 37-minute period when it's closest to the surface, and then play back the information to Earth as it flies outward to the furthest point in its orbit. The Magellan science team includes members from 5 nations, and although they will have enough data from the original mission to study for 10 years, they hope to extend the period of data gathering to enable the production of 3-dimensional maps and to fill in gaps caused by shielding of the Earth from the spacecraft by the Sun or Venus itself. Activity continuing here in the T-minus 9-minute build-in hold. We have 23 minutes remaining before picking up the count once again.
620.
Good, 161, please, sir.
Okay, copy.
And SPE NTD. SC. Okay, the IPR on the boiler problem, that is not a constraint to launch at this time. That's correct. Okay.
Launch record, escape weather on 231.
Cape Weather, go to 231. You're on 212.
Okay.
This is Shuttle Launch Control at T-minus 9 minutes and holding. We have slightly more than 20 minutes remaining in this build-in hold. The plan is to pick up the countdown at the at 2:15 p.m. and lift off at 2:24 at the present time. We do have a problem in the range safety area. One of their cyber computers is down, and this is used for a lot of the tracking information and processing of information during the ascent phase when range safety is watching very carefully to make sure everything is operating properly. We'll be standing by to see if that computer comes back up. There will be a status check that will occur approximately 6 minutes before we come out of this hold, just about 9 minutes from now, to determine what the status is. At the present time, we're at T-minus 9 minutes and holding. This is Shuttle Launch Control.
CDR, go.
Okay, just to bring you up to speed, I guess we're looking at two problems at this point in time. One is dealing with the Magellan spacecraft itself, and the other one is a computer system utilized by the range safety folks. And
okay, we've been following what we could hear of that.
Say again, sir?
I said we have been following what we could hear of that on the loop.
Okay. And we're approximately 19 minutes away as far as our picking up the count at -9 is concerned.
Atlantis, roger that, NTD.
NTD, PTC.
Go ahead, PTC.
On that little problem we were troubleshooting a little while back on the Magellan, did you get the report back from JSC Payload Ops?
No, sir.
They took the power from 10 kilowatts down to 2 kilowatts. Magellan lost the lock on the signal, and what they did was they took it back up to the full power rating. They locked back up on the signal. Now that Magellan understands the problem, they don't consider it a problem anymore, and they're going to still go for launch.
Okay, I understand that Magellan is go for launch then.
At this time, yes.
Okay, I understand.
NTD SRO on OIS 212.
Go ahead.
Roger, the 0-90-minute Gymsphere was terminated at 56600 feet, 56,600 feet. Data was transmitted to JSC loads.
Copy, thank you. And any estimate on your computer?
Negative, not yet.
Okay. NTD-SD 232. Go ahead, SD.
Okay, what was the water spray boiler IPR?
257.
Okay, and did you give one to the range?
No, I did not. That would be 258. SPE NTD. SPE NTD 212.
Stand by, NTD. You'll be right way in.
Okay.
Go ahead, NTD.
Okay, you're requesting go ahead and generate an IPR on the fiber problem?
That's your call, NTD.
Okay, I don't know that we've done that in the past, so I don't think we'll pick one up this time.
QC ISL 212.
Go ahead, ISL.
Did I have CMQC on 145?
CMQC OTC.
I copy.
Thank you.
NTD Flight 212.
RTC, CMQC.
Go ahead. Go ahead, CMQC.
Oh, okay. We need, if CNGC can get in here, we need a signature for him for a pen and ink, but no particular hurry.
Okay, that's GNC?
That's for me.
Okay, GNC, you copy? GNC copies. ITD, NTD, 212. ITD, NTD, 212. TTC, NTD, 212.
Go ahead, NTD.
Can you get ITD over on 212, please?
This is ITD. Go ahead.
Roger. Just to give you a heads up here, what we're looking at doing is going ahead and picking up at L-19 as though we were coming out of the hold and going down and breaking out if we can't get an SRO go prior to picking up the count. Does that bother you as far as doing your L-15 whole far checks?
You would pick up at L-19, and then we would go ahead and do them at L-15 as planned?
Yeah, what we'll do is we'll run the count just like we're doing it and break out at -9 if we don't get a range go by that time.
Well, this launch director clarification will hold it, continue to hold at 9 minutes if we don't have a go until the range clears their problem.
That's correct. My concern was, can you go ahead and...
This is Shuttle Launch Control at T-minus 9 minutes and holding. We have just slightly more than 12 minutes remaining in the standard part of this hold. We have approximately 36 minutes until the end of the window. The plan at the present time is to go into the checks, which occur about 6 minutes prior to picking up the count, and to see whether the range safety people have been able to get their computer working again properly, and whether we can get a go to pick up the count. This is just a 23-minute window today. The window gradually increases to almost 2 hours as we go through the month. The crew has been briefed by the team about the one transducer that's on board that is not reading the cabin pressure properly. It's believed that there may be a cap on that one sensor. However, that's not a violation of the launch commit criteria, and we can fly with that, and they can take a look at it after they're on orbit. But at the present time, except for the problem with the range safety computer, we appear to be go. There's 10 minutes, 44 seconds remaining in this 40-minute build-in hold, and we'll be standing by for a status check of all of the various test conductors who are in charge of today's launch just about 4 minutes from now. This is Shuttle Launch Control.
NTDSB 212. Go ahead. Okay. Do we have any constraints left? The only one I show is that item 171, which is IPR 256. Okay. They're in the room closing it out right now. Okay. Okay, and we're about 10 minutes away from coming out of the hold at -9. ITD, NTD.
Go ahead, NTD.
Okay, we'd like for you to go ahead and perform your whole part checks by the clock at L-15 minutes.
Roger, we'll be doing that.
Okay. And flight, NTD.
This flight?
Okay, can you activate your recorders at L-15?
Wilco, I hate to do that if we hadn't got to go from the range yet.
Okay, about how long will that take once we give you a go?
It won't take but a minute.
Okay. Okay, all personnel on 212 at this time, I'd like to go ahead and get a verification that you're ready to resume the count and go for launch, realizing that unless we get a go from SRO and the computers get back up, we're still no-go. OTC?
OTC's ready.
PBC?
PBC's ready.
PPC? Go. LPS?
LPS is go.
Flight? Flight NTD, 212. Mila?
Milo's go for launch.
STM? STM go. Safety console?
Safety's go.
SPE?
SPE's go.
CDR?
CDR is go.
All right. LRD?
LRD's go.
And SRO?
SRO still no-go. We should have word shortly.
Okay, I understand. And Houston flight?
And flights go.
Okay.
This is Shuttle Launch Control.
Director, NTD.
Our NASA Test Director now calling the Launch Director.
Okay, I can verify that the launch team is ready to proceed with the exception of the SRO getting his computer back up, and we still have to activate the recorders.
I copy, and I'll be back to you in a couple of minutes after we've had the final brief with the mission management team.
Understand?
Launch Director Bob Seek talking to NASA Test Director Ron Phelps. The Ron Phelps reporting that everyone is go, including the Mission Control Center in Houston at this time, with the exception of Range Safety, which has a computer problem. The Range Safety Officer reported that he should know in just a couple of minutes whether or not that's going to be able to be brought back up. At this point, Launch Director Bob Seek and the Mission Manager Bob Crippen consult on the readiness and all of the possible issues, and then report back on whether they are go.
Mark, we're approximately 6 minutes away from coming out of the count. SPE, NTD.
SPE?
Roger. Do we need to brief the crew as far as the pressure transducer is concerned?
Flight's going to take care of that.
Well, Flight just asked...
Yeah, this Launch Director, why don't we go do that at this time? And SPE, why don't you just give a brief overview, and Flight can add if they wish.
Okay. Wait till at the end.
CDR, SPE.
Good, listening.
Okay, CDR, during the cabin pressure test, we found that the cabin pressure sensor did not change. And the data is showing us that we have some anomaly with the sensor that is keeping it from changing state. However, the airlock differential pressure and the DPDT do work. And we wanted to make sure that you understood that your cockpit meter would not reflect any change in cabin pressure.
Okay, we do understand that.
And
we believe that also we may have a problem with the backup DPDT comp on SM System 1, is that correct?
And Flight concurs with that, Dave. You will have a problem with that
Okay,
backup.
we think we understand the situation.
And NTD, this Launch Director, I'll run part of my polling at this time. Start with payload operations. Yeah, Bob, this is John. We're go for launch this time. I copy. And Engineering Director?
Launch Director, I pulled the technical community, and you have our consent to proceed with this launch. Good luck and Godspeed.
Copy. Safety and Quality Director?
KSC Safety and Quality have no constraints for launch.
I copy. And Cape Weather?
Cape Weather, we have no weather launch constraints violated. Steady state winds for launch from 110 degrees at 12 knots.
I copy, and that will give us a 7-minute hold capability after APE start if that is required.
NTD, PTC.
Go ahead, PTC.
Okay, steps 854, 855 are complete.
I copy.
Also, steps 991 are complete, and our ASC batteries are online for IUS. steps 1014 through 1017. At this time, we'll go ahead and report that they're complete. We're ready.
I copy. Magellan's ready to resume the...
Magellan and IUS are ready.
Okay.
This is Shuttle Launch Control. We have about 2.5 minutes remaining in the planned part of this hold. We're about to hear Launch Director Bob Seek and Mission Manager Bob Crippen discuss the readiness to go.
Countdown clock will start in 2 minutes on my mark. 3, 2, 1, mark. Ops Manager, Launch Director.
Roger, go ahead, Launch Director.
Okay, want to confirm you have a go to proceed.
Roger, you have a go to continue with launch from the mission management team.
I copy. And NTD? NTD, go. Okay, what's the status from range safety at this time? SRO?
NTD SRO, we're still no-go, waiting for further word from safety.
This is Shuttle Launch Control, a report from the range safety officer.
Yes, sir, go ahead. Okay, we'll want to cancel pending. I copy.
The range safety computer is still not up. It's been announced that we will not be coming out of the hold on time.
Go ahead, ITE.
Hold fire system is enabled.
I copy.
We have about 24 minutes, 45 seconds remaining in the capability to hold. That's a 24-minute or 23-minute launch period for today. We were supposed to come out of the hold at 2:24 p.m. Eastern Daylight Time. As it is, we are standing by to listen to a call from range safety about whether or not they are able to get their cyber computer back up and operating.
Configuration. I copy. And PVD to copy.
I copy. We'll proceed with payload bay flow rate reduction.
Understand.
At this point, we have had a check of all of the various test conductors who are monitoring today's launch.
We can get a confirmation from the range on their estimate here to try to clear the problem. What I'd like to do, if it looks like they're going to be having some success there, to go ahead and pick up the clock and put a hold pending in at -5 minutes and go back into a hold there if there's still no go. SRO copy.
I copy. I'll have to discuss that with the range safety officer.
NASA Launch Director Bob Seek proposing a plan to pick up the count and proceed down to the 5-minute point and then hold once again if the range safety computer has not come back up. At this point, all elements of the launch team and the mission management team have concurred that they are go. The range safety cyber computer is the only problem at the present time.
QC.
Go ahead.
Okay, constraint. Line item 171 has been lifted.
Copy.
The superintendent of range operations conferring with the range safety officer on the plan to pick up the count and proceed down to the 5-minute point. We should hear back from that shortly. 22 minutes and 12 seconds remaining in the window.
Go ahead, PD.
Okay, flow rate reduction is complete. Be advised that we dipped a little bit below the LCC when we were ramping down. They were back at normal interface pressure.
I understand. Thank you.
And,
a report coming back on the reduced flow rate of air through the payload bay. That 21 minute and 45 seconds remaining in the window for today's launch takes into account that we would be starting at the T-minus 9-minute point. So it's really about 30 minutes before the close of the window. However, we have some very significant things to do in the remainder of the countdown before we get to liftoff. So we'll stand by.
OIS 212. Go ahead, SRO. Roger, you have a final clear to launch from the range.
A final clear to launch from the range computer up and operating.
NPD, 212. Roger, copy that. Atlantis, launch director.
Atlantis, go.
Okay, well, I think we finally got everything cleared up down here, Dave. Your payload and shuttle are in great shape, and the ground systems are in a support mode, so we'll wish you a good one. And NPD, you have a go. Go ahead, launch director. Roger, you have a go to proceed. I understand.
And NTD Flight 212.
Go ahead, Flight.
We will have a mode boundary update for the crew here as soon as we can get it. You can press on.
Okay.
So Shuttle Launch Control standing by for word from the NASA Test Director.
Flight, CISL, COEX, and JRPS, go ahead and activate your recorders at this time.
Flight copies. And work.
ISO copies. OAS copies. Okay. And TLS, why don't you go ahead and pick up the count on your mark.
I copy. Stand by, please.
Okay.
We'll see for 1820 GMT.
And flight, NPD.
Does flight go?
Okay, I did interpret that as you got to go at this time to pick up the count.
That's affirmed, and we do have the boundaries to read to the crew.
Okay.
You ready to go ahead and do that?
Go ahead.
We'll be picking up the count in just 40 seconds from now.
Atlantis, Houston, with some deltas to your mode boundaries.
Ready to copy, Houston.
Roger, due to the slight change in launch time, new press to ATO, 11.7.
Stand by, please.
Press to MECO, 13.6.
Resume on my mark. 2, 1, mark. T-minus 9 minutes and counting.
And we're at T-minus 9 minutes and counting. The countdown clock proceeding. The ground launch sequencer has been initiated, and from now till T-minus 31 seconds, when we begin to switch over to the onboard computer, that will be in command. The ground launch sequencer is part of the launch processing system and operates by relaying commands to the onboard computers, which then report back that the commands have been executed. 8 minutes, 30 seconds, and counting.
10:30, not performed. STM copies, thank you. NTD, ISL. Go ahead, ISL. Recorders activated. Copy.
The recorders have been activated. T-minus 8 minutes, 15 seconds, and counting. The primary job of the onboard computers is to check that all of the launch commit criteria are within limits. Coming up on the 8-minute point.
Yes, sir. Can proceed with transmission of stored program commands.
Wilco?
It's in work.
We've passed the 8-minute point, and the crew has been notified and flight notified that they can proceed with the stored program commands. This is a final update on antenna management and frequency changes. This ensures the orbiter has the latest information to speak to the TDRS satellites and ground stations. T-minus 7 minutes, 30 seconds and counting, and the orbiter access arm is retracting. This is the walkway used by the astronauts to enter the orbiter. In case of an emergency, the arm can be placed back into position within about 15 seconds. Coming up on the 7-minute point in our countdown.
Yes, sir. Start your APU and hydraulic recorders by the clock at 6 minutes. I copy.
T-minus 7 minutes and counting. Everything proceeding smoothly as we move down towards a liftoff at 2:29 this afternoon. T-minus 6 minutes, 40 seconds and counting. Pilot Ron Graby will be asked to set the switches in the cockpit to the pre-start position for the auxiliary power units, or APUs, at the 6-minute point. This consists of positioning a number of switches and verifying that they are in the proper position. then throwing the 3 propellant isolation valve switches, which allow the hydrazine fuel to start flowing from the tanks toward the APUs. Coming up on that 6-minute point in 12 seconds.
PLT, OTC.
OTC, PLT.
So perform APU pre-start.
APU pre-start and work.
Pilot Ron Graby reporting that pre-start is in work. T-minus 5 minutes, 45 seconds and counting. In just a few seconds, Mission Control will transmit the signal to start the onboard flight recorders.
OTC, PLT, APU pre-start complete. Great talkbacks on 1 and 3, Barber on 2.
Copy that.
Pilot Ron Graby reporting pre-start is complete. At the T-minus 5 minute point, the orbiter test conductor will ask Pilot Ron Graby to start the auxiliary power units, which provide hydraulic power for steering and controlling the flight surfaces. 10 seconds away from that 5-minute point.
Yeah, let's just go for orbiter APU start.
PLT, OTC, perform APU start.
OTC, PLT, APU start and work.
And CDR, OTC, reconfigure heaters.
Pilot Ron Graby now flipping the 3 switches in the cockpit to start each of the 3 APUs. The liquid oxygen replenishing of the LOX tank has been terminated. At this point, the liquid oxygen fill and drain valve is closed, and at the same time, cold hydrogen gas is flowing through the main propulsion system to
DGT2 on APU 3 at 6.6-7, where I still go to 1 and 2 man towards instrumentation only.
Copy that.
And PD copy, SD copy, SD copies.
This OTC.
OTC.
T-minus 4 minutes and counting.
Let's go for purge sequence 4.
The main engine final purge sequence is underway, and the orbiter flight control surface, such as elevons, speed brakes, and rudders, are now being moved through their pre-programmed position to verify they are ready for launch. T-minus 3 minutes, 40 seconds and counting. T-minus 3 minutes, 30 seconds and counting, with all 3 engines now being moved through a pattern to verify their readiness for ascent flight control. After going through their pattern, they will be aligned to their start positions. We're coming up on the 3-minute point. At 2 minutes, 55 seconds, the start of the external tank liquid oxygen pressurization will begin. T-minus 3 minutes and counting. The ground launch sequencer has sent a signal.
LO2 pressurization.
Has started to retract the gaseous oxygen vent hood or beanie cap on the external tank. The computers will make a final check to ensure the vent arm is fully retracted at the T-minus 37 second point. T-minus 2 minutes, 30 seconds and counting.
OTC, PLT, go.
Clear caution and warning memory and verify no unexpected errors.
The orbiter test conductor has asked Pilot Ron Graby to clear the caution and warning system. He's reported there's no unexpected errors. T-minus 2 minutes, 12 seconds and counting. Liquid hydrogen replenish of the external tank will stop in 5 seconds and pressurization get underway.
Close and lock your visors and initiate O2 flow. And have a good flight. And PLT, OTC, turn on debris camera at T-minus 10 seconds.
Yeah, let's just go for ET LH2 pressurization.
Orbiter test conductor Mike Key telling the crew to close their airtight visors.
Thank you for this fine station.
Coming up on the 90-second point, 90 seconds, and we're less than 2 minutes away from launch of STS-30 and its crew of 5. At the T-minus 1 minute point, the ground launch sequencer will verify that the shuttle main engines are ready to start. The liquid hydrogen tank now at flight pressure. Coming up on the 1 minute point in our countdown. T-minus 1 minute and counting. The liquid hydrogen tank at flight pressure, the sound suppression water system now armed. Pre-liftoff water will...
31 seconds due to an RSLS hold.
We will hold the clock at T-minus 31 seconds. We have had a report. We will hold the clock at T-minus 31 seconds.
Stand by, sir.
This is to me. We launched low pressure fuel pump discharge press, engine 1.
The countdown clock is holding at T-minus 31 seconds.
We're at T-minus 31 seconds and standing by to hear what the problem is.
We're going to have to recommend a recycle here. It looks like the pump is actually down.
Okay, Launch Director SP, is there anything else we can look at here before we go to a recycle?
C-prop, anything else?
Negative. We've lost research on this engine. We're out of limits. We're out of engine rating.
Okay, NTD, let's recycle.
And as Launch Director, C-prop, the condition we're in right now, does it present any safety problems, or is this a standard recycle for us?
C-prop is viewed as a standard recycle, no safety problems.
Okay, well, if there's nothing else we can try at this point, NTD, you have a go for recycle. Okay, GLS, NTD.
Yes, sir.
We'll go ahead and give cutoff.
Copy.
And NTD Flight 212, we're going to go ahead and clear our SPCs.
Copy.
Launch Director Bob Seek telling the NASA Test Director that he has a go to cut off and recycle. At this point, there would not be enough time to recycle and launch today. The orbiter access arm being placed back into position against the orbiter to allow the crew to egress at the proper time. However, there is no problem with the recycle at this time. There's no danger to the crew.
Perform APU shutdown.
Roger, APU shutdown and work.
Pilot Ron Graby reporting that he has APU, auxiliary power unit, shutdown in work.
Fire detectors tripped at this time.
And NTD C-prop.
Go ahead, C-prop.
Yeah, the engine 1 pump did come back online. It looked like it was cavitating, so we terminated all 3 research pumps.
Copy.
The launch team going through a recycle from the T-minus 31 minute or 31 second point. They'll be going back to T-minus 20.
Yeah, we're calculating. We'd like to give that to you post-test. Okay, copy that. CDR and PLT OTC. Perform cutoff safing switch list.
Okay, interrogative the heater activation.
The test team going through the process of recycling now from the launch configuration. The countdown for launch of STS-30 and the Magellan spacecraft to Venus halted at just 31 seconds prior to launch. Problem with the recirculation pump is what has been mentioned. We're standing by to hear more information on the problem which occurred. The gaseous oxygen vent arm or beanie cap being replaced on top of the external tank to carry away any vapors boiling off from that tank.
GPC mode 5 switch to standby.
It's in standby.
Copy, panel R1. PLT, power distribution essential bus source. Fuel cell 1, 2, and 3 switches to off.
Copy, essential bus source 1, 2, and 3, essential bus to fuel cell coming off.
Copy that, and PLT on panel F8. Flight controller power switch.
PLT.
Flight controller power switch off.
OTC PLT, flight controller power is off.
Okay, copy that, thank you. CGSS OTC.
CGSS verifies OA is extended and locked.
Copy.
So Shuttle Launch Control, the flight crew, primarily Commander Dave Walker and pilot Ron Graby in the cockpit doing the necessary switch throws to safe the orbiter. They have shut down the auxiliary power unit and have shut down the fuel cells which are used to produce electricity while in orbit. In the meantime, the launch team continues to go through the necessary procedures in order to recycle the countdown back to the T-minus 20-minute point. And we're standing by. We have heard that there's a recirculation pump problem that caused us to be outside the limits of the launch commit criteria. However, have not had an explanation of exactly what happened.
Copy that, DPS, OTC. CDPS, OTC. This is DPS, we copy. Okay. CDR, CDPS. CDR, go. Panel C2, right CRT, select switch to 3. We'll go. And CRT 1, 2, and 3 major function switches are GNC. That's complete. On the right keyboard. Go ahead. Message reset. Complete. Up 000. Okay, you want this on the pass of the VFS, CPDS? I want this on the BFS. Okay, we'll do it on the VFS. I understand you want an ops 000 pro. That's right. Okay, that's complete, and break for OTC, CDR. Give me some words on whether or not you want the heater activation called for in the recycle procedures or not.
This is Shuttle Launch Control. The launch team still in the process of recycling from the T-minus 31 second point. Right at this point, there is really no additional information on exactly what the problem is. Although a recirculation pump has been mentioned, it is also possible that there might be a sensor problem or some other type of problem, so it is premature at this time to make any conclusion. The mission manager, Bob Crippen, is standing by for an explanation from his mission management team as well.
Copy that, NTD, you copy. And BLT, you have a go to shut down the heater. NTD, TBC. Go ahead, TBC. Yeah, for 0037, ET heaters have been activated. Copy. Okay, all personnel on 212, stand by for post-cutoff safety checks.
The launch team about to go through the safety checks to determine that the vehicle is in a safe condition.
Verifies number 1. DPS. DPS verifies. SME verifies 3 and 4. CCME verifies 2.1. MPL verifies 5 and 6. LXY. LXY NPD 212. CLHY, go ahead. Can you verify item 7 and 8 and 9? Let's verify. C-Lock. C-Lock verifies 10 and 11. ATD. Horace, you're on 245. ATD, NPD 212. This is ATD, go ahead. Can you verify item 12? We can verify. Okay. CGSS. CGSS verifies item 13. APU. APU verifies 14. CHY. CBHY verifies 15. ETD. ETD verifies 16, 17 does not apply. OOS. COOS NTD. Go ahead. You verify 18. That's confirmed. C-Power. C-Power verifies 19. And DRS. DRS verifies 20. Okay. RSR NTD 212. Go ahead. Okay, post-cutoff safety checks complete. Fire and leak detector status is satisfactory. Request concurrence to proceed with SRB SNA safety. RSR concurs. Okay. OTC NTD.
Go ahead.
Pick up with step 42, SRB RSS SNA safety.
Copy that. C-Power, OTC.
C-Power, go ahead.
Verify ignition, SNA safe.
That's verified.
Copy that. And DPS, CPD?
Copy.
DPS, copy. DEU equivalent critical commands will be issued momentarily. CLS, OTC.
Go ahead.
Perform SRB, RSS, SNA safing, post G9 recycle.
I copy and work.
This is Shuttle Launch Control, the launch team continuing to go through their paces and the vehicle.
Yes, sir. We believe we may have missed a step on L2. We need to get the flash event feed line heaters 2 to 2.
CDR, OTC. CDR. Okay, panel L2, flash event feed line heater, A and B supply switches to 2. That's complete. Thank you, sir.
Pilot Ron Graby being asked to flip one more switch, which has to do with heaters on the water spray boilers. The vehicle in a safe condition at the present time, but still a lot of work to do to get it back into the T-minus 20-minute point and then recycle it completely.
Panel C3.
At this point, we are standing by to learn more about the problem which caused the scrub of today's launch at the T-minus 31 second point. The recirculation pumps which provide for the proper configuration of the main engines prior to engine start appears to be a problem. This could be a ground support problem, but it's too early to say that definitely.
TBC and TD. Yes, TBC. Okay, you want to go ahead and kick off step 61? TBC, copy.
PLT, OTC.
OTC, PLT, go.
Yes, sir, on panel R2.
Go ahead.
APU hydraulics, APU controller power, 1, 2, and 3 switches off.
Roger, APU controller power, 3 switches are off.
Copy, and hydraulic main pump press, 3 switches normal.
Hydraulic main pump press, 3 switches are normal.
Just as during the launch countdown, a recycle of the launch vehicle proceeds according to procedures as part of the total 5-volume set of procedures that are used for preparations for launch, and then recycle or any contingencies that might occur.
MPS helium ISO A, 3 switches, GPC.
And helium ISO B, left, center, and right switches, GPC.
Helium ISO B, 3 switches to GPC, complete.
Pneumatic helium ISO switch, GPC.
That's complete.
Copy that, thank you.
CLHY TBC, you go to 136, please. Okay, all personnel on 212. At this time, the decision has been to scrub for today. We will not perform steps 59 and 60. And we'll pick back up on page 984 with step 62. TBC? TBC NTD. TBC NTD 212. TBC NTD 212. TBC. Okay, you've got step 61 in work, and I'll give you step 62 at this time. I'm sorry. It is TBC on 212. Okay, 62 is not performed, so you're working 61.
That's right. 62 is not performed. 61 is in work. Or is complete.
And OTC is critical safety complete?
It is complete, sir.
Okay.
And OTC, TBC, could I have a DPS on 136?
And step 64 is not performed?
Yeah.
Okay, and OTC NTD?
Go ahead, sir.
Why don't you go ahead and put step 65 in work?
Copy that. GNC, OTC. CGNC, OTC, 212.
Go ahead.
Okay, step 65, sir, on page 985.
I copy.
And OTC, DPS, step 66 and 67 are complete.
Copy that.